Hi everyone. Welcome to the class. Can you see me? Can you hear me clearly? Am I visible? Am I audible? I want a quick good to go from everyone. Am I perfectly visible, perfectly audible to each one of you? Give me a quick good to go in the comments. We're going to dive into the discussion of binomial theorem today. It's a fantastic high weightage topic for your JEE Main exam. It's also high weightage for JEE Advanced. But right now, because we are so close to our JEE Main 2025 January attempt, I guess we should, in a streamlined manner, just focus on excelling at our January attempt. You already know the stakes are too high, everyone. April attempt, we cannot rely too much upon it because as it is, the competition will increase. There are droppers. Yes, and of course, there is going to be increase in the cutoff as well as seen in the past if you analyze the previous trends in the previous years. So January is what we have all our bets upon. We have to put in our 200% to perform exceptionally well in January. And it's my promise to you, if you stay throughout the session from start to end, from binomial theorem, the 4 to 8 marks are guaranteed to go in your pocket 100%. So tell me, can you see me clearly, hear me clearly? Everybody give me a quick good to go in the comments. Am I perfectly visible and audible to each one of you? Yup, Abhishek, each and everything. When I say each and everything, I mean each and everything. All right. Hello, Navansh. Hi, Abhishek. Dharan is also here. Hi, Nidhi. So good to see you. Nidhi has been a regular student from past so long. I have known her, taught her. She's been a very diligent student. It's lovely to meet old students anytime. So everyone out here, please meet Nidhi. Nidhi, everybody. All right. All the chapters, all the topics, all the supremely important concepts which are going to hold high weightage in your upcoming exam, which are in the favorites list for the examiners. That is what I am going to share with you throughout this session and the sessions coming ahead. Okay. Everybody, please tell me quickly, visible, audible, everything is perfect? Everything is perfect. Give me a quick good to go. 4-1 last time. Give me a quick good to go. We're going to dive into the discussion of binomial theorem. People, thumbs up. You can see ma'am. You can hear ma'am. Audio, video, perfect. Yes? Good to go. Perfectly visible and audible. Guys, let's get started. So when I talk about binomial theorem, the very first prerequisite that you need always is what is factorial and what are some of its formulas. So let's go quickly. Let's breeze through the formulas. I will not dive into too much of the derivation because right now all we are interested upon is exam-oriented study. Of course, I will be teaching you every little subtopic which falls inside this chapter, which holds primary weightage for your upcoming JEE Main exam. But having said that, I will be sharing proofs with you which are important for you to know and which will help you remember the formulas for a long period of time. But there are certain proofs where you need not spend your time in. I'm being very frank. There are certain proofs, certain derivations which are just time waste at this stage of our preparation. So those, no need. But wherever you are required to do the proofs and derivations, ma'am has got you covered. So let's get started, everybody. NCR. There are multiple ways in which you write NCR. It's like this, or like this, or like this. You all are aware? Yup. What does it denote? It denotes the number of ways in which you can choose R distinct objects out of n available distinct objects. Alrighty. So remember the language, remember the definition, remember the notation. How do you express it? You express NCR as n factorial upon R factorial into n minus R factorial. Guys, this is the foundation of PNC, foundation of binomial. Is this clear? NCR is n factorial by R factorial into n minus R factorial. Please remember a very minute detail attached here. Whenever you write NCR, guys, antennas all straight, all up. NCR, when you write NCR, n has to be a natural number, R has to be a whole number, and R varies from 0 to n. The upper index n, the lower index R, or the subscript, superscript, whatever you wish to say, right? N has to be a natural number, R has to be a whole number, R varies from 0 to n. This is when NCR holds valid. Otherwise, NCR is not valid. So when you say 11C5, valid. When you say 21C3, valid. But when you say 10C12, not valid. Not valid. The number sitting at the bottom should not exceed the number sitting at the top. The number sitting at the bottom should not exceed the number sitting at the top. You will say, ma'am, such a minute detail you are explaining. Trust me, people, when we move ahead to binomial series results, that is where this minute detail creates massive difference in the outcomes that we get. So remember this, NCR is valid whenever R is less than equal to the upper index, which is N, and obviously it has to be non-negative compulsorily. Alrighty, can I move ahead, everyone? Yes. Look at the results. NC0, obviously, you know, number of ways in which I can choose 0 objects from the available N objects is 1. Apply the formula again, you get 1 only. NCN, number of ways in which I can choose all the N objects from the available N objects. Again, it's 1 only. You can apply the formula and cross-check as well. Very simple, super duper easy. Now, moving ahead. There are 4 results which you have to remember on your fingertips. Guys, if I wake you up in the middle of the night and ask you, these 4 results, you have to vomit out straight on my face, literally. When I wake you up at night, ask you, what were the 4 results, the superstar results, the foundation results, the primary results, which govern every other subsequent concept that we're going to study? It's these 4 results. What are they? Number 1, everybody, eyes pop open, ears pop open. Number 1, NCR is NCN minus R. NCR is NCN minus R. You're going to use it in a very dense manner. You're going to use it again and again and again and again. It's going to slide its way through all the questions, almost all the questions. It's a beautiful, beautiful result. Cannot afford to not remember it. Next up, what does this say? What does this say? Look at this. NCR equals NCS provided either R is equal to S or N is equal to R plus S. What does this mean? This is very intuitive. This is very, very obvious. See, when you say NCR is equal to NCN minus R, this is one result I just taught you. Next up, it says NCR equals NCS. Now, it's but obvious. 5C4 is equal to 5C4. Yes or no? 5C4, yes, is equal to 5C4. So, NCR equals NCS. One of the possibilities is that R is equal to S. This is the perfect identical condition. Or, one more thing can happen. NCR is also equal to bache N minus R. So, this S can also be equal to N minus R. That's another possibility. This means what? That S plus R is equal to N. That is why whenever you say NCR equals NCS, there are 2 conditions which fall upon R and S. Either they both are equal, so that we have exactly identical expressions, NCR equals NCS, R equals S, right? Or remember, S is nothing but N minus R, or R plus S is equal to N. Alrighty, 2 results we are down with. Moving on to the next one. Everybody, eyes on the screen, very attentive. Look at this one. This is called consecutive coefficient property. What is this called? Consecutive coefficients. Property of consecutive coefficients. Why? What does it say? NCR plus NCR minus 1 is N plus 1 CR. So you can see the upper index is matching. The upper index is matching. The lower indices are differing by 1. R is the big brother, the big bro, and R minus 1 is the younger brother. Yes or no? So NCR plus NCR minus 1, increase the upper index by 1, you get N plus 1 C and then the big brother. N plus 1 CR. Remember? Yes or no? Yes or no? Remember? NCR plus NCR minus 1 is N plus 1 CR. Very, very important consecutive coefficient property. Okay, R minus 1 are consecutive partners. Moving ahead, the next one. Moving ahead, people, the next one. This was your 3rd result. What is the 4th result? What is the 4th result? NCR upon NCR minus 1 is N minus R plus 1 upon R. Very, 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 very important. This is also called the rich-poor property. Why is it called the rich-poor property? Understand the way I'm writing it is going to explain everything. NCR. This is simple. Upon NCR minus 1. So ऊपर there is r, नीचे there is r minus 1. What is on the right hand side? What is on the right hand side? N minus r minus 1. N minus r minus 1 whole upon r, which gives you n minus r plus 1 upon r. Yes ma'am, no ma'am. Everybody clear? NCR upon NCR minus 1 is n minus r plus 1 upon r. Don't cram this. Just remember it like NCR upon NCR minus 1 above r, below r minus 1. Okay? So the above, the numerator has a bigger lower index. The denominator has a smaller lower index. What will happen? What will happen? N minus r minus 1 whole upon r. That's it. Remember the design. The design through which we are getting the right hand side. Don't cram the right hand side. This is the fourth results. All these results are very important. Very, very, very important. No doubts about it. Okay, making sense? Making sense, everyone? So what are the four results? Quickly write everybody in the chat. What are the four results? Number one, NCR is equal to NCN minus R. Number two, NCR equals NCS, which means either R is equal to S or N minus R is equal to S. Number three, what is it? NCR plus NCR minus 1 is N plus 1 CR, the consecutive coefficient property. Number four, NCR upon NCR minus 1 is N minus R plus 1 whole upon R. Yes? Yes? No? Quickly tell me, people. Is this making sense? Is this screen visible? Am I visible? Yup, you can. Alka is very correct. Motu patlu, rich poor, Amir Garib. There are many, many ways to kind of remember it. But again, people, I'm saying this to you. If I wake you up in the middle of the night, the first thing you have to say before you even open your eyes, the moment you're conscious, are these four results. Yup. Corner mein hu yaar main. This is corner. Fine. I have made myself fix in the corner so that you can see the screen carefully and clearly. Chalo. Let's go ahead, everybody. Let's go ahead. Take a look at the next one, which I will be talking about even aage. So right now you can just see and remember it. What is it? It says NCR. It's a very interesting result. It's very, very interesting. NCR is N by R. So whatever is on the top, on the bottom, take the ratio. One less upar, one less niche. N minus 1 C, R minus 1. Is this making sense? So NCR is N by R. Whatever is on the top, whatever is on the bottom, take the ratio. One less upar, one less niche. N minus 1 C, R minus 1. So how I remember it as is NCR. When you take N by R, one N, one R has been used. You're left with one less N, one less R. Eventually, your coefficient is going to look like N minus 1 CR minus 1. Very, very good. Very, very good. Is this clear? Is this clear? Is this clear? Alrighty then, let's move ahead, people. Let's attack this question. It's a JEE Main PYQ. I want all of you all to brainstorm upon this. Tell me how will you crack it. So in total, I've shared with you 5 results. NCR is NCN minus R. NCR is NCS when either R is equal to S or when S is N minus R. Next, NCR plus NCR minus 1 is N plus 1 CR. Next, NCR upon NCR minus 1 is N minus R plus 1 whole upon R. Next, NCR is nothing but N by R, N minus 1 CR minus 1. I have shared with you 5 results. Am I absolutely clear? Am I absolutely clear? Am I absolutely clear? Till here is everything hashtag HDCC, high definition crystal clear. Till here everything is hashtag HDCC, everybody. Till here everything is hashtag HDCC. Yup. Let's go then. What does this result say? 40C0 plus 40C1 plus 41C1, 42C2 and so on. How do you think will you attack this? How do you think you will attack this? How do you think you will attack this? Any clue, anyone? I want all of you all to tell me Is there any direction in which you feel you can think, and then we can proceed? Chalo, come on, brainstorm. Quickly brainstorm, tell me. What should we do? Alka is saying NCR is NCR minus 1 wala pehle LHS lagayenge. Okay. By adding 40C1, Yash, make sure that you are cross-checking your thoughts. Ankur, very good. Okay. Very good. I guess Tirupati. Somebody whose YouTube name is Tirupati. Highly impressed. Look here, people, and try to understand how I am kind of moving in the direction of the right approach. Look here. It says 40C0 plus 41C1 plus 42C2 plus and so on 60C20. Look at this. Carefully look at this. Is this clear? Yahan tak, or I'll write it here. Just wait. If this is getting hidden, I'll write it here. It's okay. So this is 40C0 plus 41C1 plus 42C2 plus 43C3 plus and so on. I'm going to write, this is 60C20. This is your expression. Now look at the smartness. I'm going to manipulate my expression a bit. You already know 40C0 is 1. Also 41C0 is 1. No. So I can alternatively write this as 41C0. This is my major manipulation, people. This is the only tricky step involved here. Otherwise, this question is a cakewalk. It's super simple. It's easy peasy lemon squeezy, trust me. What will I get next? This is 41C1, this is 42C2, this is 43C3 plus and so on till 60C20. Yes? Clear till here? Now here I'm going to use my consecutive coefficient property. Remember? NCR plus NCR minus 1 is N plus 1 CR. How many of you all understood? 41C1 plus 41C0 will land you with 42C1. I have used my consecutive coefficient property. I am telling you, people, time and again, JEE Main has tested students on just these 4-5 properties, which I've shared with you right in the beginning, based upon your binomial coefficient, which is NCR. These 4-5 formulas, if you remember on your fingertips, questions like these are a cakewalk for you, +4 in a jiffy. In a fraction of a second, you can earn these 4 marks. Okay, so very smart strategy. Next up, we have 42C2, then we have 43C3 plus and so on, 60C20. Again, look here, 42C2 plus 42C1 will give you 43C2. Now, 43C2 plus 43C3 will give you 44C3. Up next, the term will be 44C4. So, they will combine to give you 45C4. Yes or no? Yes or no? And like this, if you observe the pattern, eventually, till right before 60C20, what will you get? You will get 60C19. Eventually, in the end, you will have 60C20. And towards the end, for the very last time, you will apply the consecutive coefficient property to get 61C20. Yes, you are correct. Yash, absolutely correct. Bingo, guys. 61C20 is the right answer. I am not expecting you to again and again apply the consecutive coefficient property. Just apply once and twice and then observe the pattern, follow the pattern, reach the conclusion. This should be on. This should be supremely attentive. Apply the property once, then again apply the property twice, apply the property at max thrice. You should be able to see the pattern which is going to follow next. And you should be able to anticipate and foresee what eventually you will be getting as the answer, which is 60C19 plus 60C20. That is nothing but 61C20. Making sense? No, 61C20, Alka. 61C20. Absolutely perfect. Perfect. Now your answer is 61C20. Look here. Yes, this is given to you as M by N 60C20. Okay, not a problem. Not a problem. I am saying 61C20 is given to you as m by n 60C20. Now I have to compute m by n, right? So what will I get? I will get 61C20 upon 60C20 is m by n. Now a lot of students commit this mistake. They try to remember one of the properties which I've taught you right now. What is that property? NCR upon NCR minus 1 is n minus r plus 1 whole upon r. They kind of get the feeling, the vibe that, okay, here two binomial coefficients are getting divided, and hence, what is the property which ma'am taught us? This one, the Amir Garib, the rich poor, the Motu Patlu property. Upar there is Motu sitting, niche there is Patlu sitting. So how exactly is right hand side getting designed? This property ma'am has taught. But this property will not be applied here. This property will not be applied here. No people, it won't be applied here, because here 61 and 60, the upper index is not matching. And you can look at the left hand side, the upper index has to match NCR minus 1. And that is why here we are not going to apply the property. Please don't be in a hurry. Do not be in a hurry ever while solving math. You have to very patiently, with a lot of focus, by cross-checking not just your thoughts, but your steps and your answers as well. That is how you have to proceed. It's math at the end of the day. One silly mistake can cost you a lot. It can cost you your dream college, people. Mind it. Be careful, be sharp, be focused. Here I will get what? 61 factorial upon 20 factorial, 41 factorial. And here you will get what? 60 factorial, 20 factorial, 40 factorial. Right? This is equal to m by, I'm simplifying, I'm just simplifying. 61 factorial will give me 61 into 60 factorial. Yes, so this gets cancelled out. This gets cancelled out. 41 factorial will be 41 into 40 factorial. This gets cancelled out. So 61 by 41 is m by n. Obviously, they are co-prime, and hence m plus n will be 61 plus 41, which is 102. Option B. People, are you getting option B? Option B is the right answer. Everyone, any confusion till here? Any confusion till here? Shall I move ahead? For one last time, people, 5 properties should be on your fingertips related to NCR. NCR is NCN minus R. NCR is equal to NCS when R is S, or when S is N minus R. Then NCR plus NCR minus 1 is N plus 1 CR. Next, NCR upon NCR minus 1, Motu Patlu, is equal to N minus R plus 1 upon R. Number 5, NCR is nothing but N by R, N minus 1 CR minus 1. Hashtag HDCC till here, because only then I will move ahead with the primary topic, which is binomial theorem. Everybody sitting here, please tell me in the chat, is everything hashtag HDCC, high definition, crystal clear? Just like there is Wi-Fi, which helps us connect our phones and our gadgets, it helps us connect smoothly to the internet. Similarly, every question, once you absorb, once you understand, you can say, ma'am, it's bhoomified, right? When you say hashtag bhoomified, that means the question is completely crushed and the connection between me and the question, between you and the question, has been established successfully, smoothly, perfectly. Okay, so 2 hashtags I'm going to use a lot in my class. One is hashtag HDCC, other is hashtag bhoomify. Alrighty, 200 questions on the way. Let's go. I hope you know binomial theorem is something which I hope everybody by now is well versed with. A plus b raised to the power n, where this n is a natural number. What is it? How is it described as? NC0 a to the power n b to the power 0 plus NC1 a to the power n minus 1 b to the power 1 plus and so on NCn a to the power 0 b to the power n. Please remember this, guys, when you compactify it, when you compactify this entire binomial expression into the summation format so that it looks short, precise, how is it expressed? Summation NCR a to the power n minus r b to the power r, where r runs from 0 to n. Where r runs from 0 to n. Okay, hi Arul, so good to see you. Summation NCR a to the power n minus r b to the power r. Is it clear? Is it clear? Everybody right now, quickly close your eyes for a second. Recollect this formula. I'm sure you've studied it before. Just try to internalize it. Try to absorb it. Try to accept it. Try to make it sink in your body, in your system. All right. What is it? A plus b whole to the power n is summation NCR a to the power n minus r b to the power r. R runs from 0 to n. This is the soul of the chapter. This formula is the soul of the chapter. There are certain properties which you should know revolve around this formula. First, when you say a plus b to the power n, look at the number of terms which are there in the expansion. Any idea, anyone? Yes, it's the general formula. It is the general formula. Tell me how many terms are there in the expansion. You have NC 0, the term having NC 0, then the term having NC 1, then the term having NC 2, and so on, term having NC n. From 0 to n, how many terms? N minus 0 plus 1, n plus 1 terms. R is varying from 0 to n. That means there are going to be how many terms? 1 corresponding to 0, then 1, then 2, then 3, and so on, then n. So from 0 to n, n minus 0 plus 1, n plus 1 terms. Always remember this. Very good, Alka. Bang on correct. N plus 1 terms in this expansion. Needless to say, in every term you had NC0, NC1, NC2, NC3, and so on, NCn. These are called binomial coefficients. These are called binomial coefficients. All right. Index of A decreases from n to 0, but index of B increases from 0 to n. Can you see this? Can you see? It's very difficult. It's not very difficult to observe this. Look here. See, NC0, NC1, NC2, and so on, NCn. These are binomial coefficients. Look at the index of A. First it's n, then n minus 1, then n minus 2, and then 0. So index of A is decreasing from n to 0. Index of B, 0, 1, 2, n. Index of B is increasing from 0 to n. Why is this happening? It's happening in a very systematic, in a very symmetric manner, so that as a result, the sum of indices of A and B in every term turns out to be the final index, which is n. Look at the first term, a to the power n, b to the power 0. Add the powers n. Look at the second term, a to the power n minus 1, b to the power 1. Add the indices n. Look at the third term, a to the power n minus 2, b to the power 2. Add the indices n. So power of A is decreasing from n to 0. Power of B is increasing from 0 to n in such a way that whenever you add the powers of A and B, in every term the answer is equal to n. N is the final actual index, A plus B to the power n. Yes, absolutely correct. Am I making sense? You have to absorb this, absorb all these details so that when we apply these in the questions, it comes out very intuitively from within you. It should be very, very natural. Getting my point? Sharing with you some more properties. The coefficient equidistant from the beginning and the end are equal. See, when you write, say when you write a plus b to the power 5, what do you get? 5c0, a to the power 5, b to the power 0, plus 5c1, a to the power 5 minus 1, b to the power 1, then 5c2, a to the power 5 minus 2, b to the power 2, then 5c3, a to the power 2, b to the power 3, then 5c4, a to the power 1, b to the power 4, then 5c5, a to the power 0, b to the power 5. So this has 6 terms. Your index is 5. Number of terms is 6. You can clearly see. And one more very beautiful observation. 5c0, 5c5. Binomial coefficient of the first term, binomial coefficient of the last term. Or I can say binomial coefficient of the first term from the beginning and first term from the end are equal. Binomial coefficient of the first term from the beginning and first term from the end are equal. Why? Because NCR is same as NCn minus R. 5C0 is same as 5C5. These both are actually same. I'm not saying terms are same. No. I'm not saying the terms are same. I'm just saying the binomial coefficients are same. Yep. Similarly, second term from the beginning, second term from the end, their binomial coefficients are also same. Why? Because NCR is same as NCn minus R. 5C1 is same as 5C5 minus 1. That means 5C1 is same as 5C4. Third term from the beginning, third term from the end. Again, the binomial coefficients are matching. It's the same. It's identical. It's ditto photocopy. Why? NCR is same as NCn minus R. Such a powerful property, people. just imagine now the binomial expansion, binomial coefficients of first term from the beginning, first term from the end, same. Second term from the beginning, second term from the end, same. Third term from the beginning, third term from the end, same, and so on. So beautiful. So beautiful. Next up, it says kth term from the end is equal to n minus k plus 2th term from the beginning. Very important. Highly applicable in questions. Highly applicable in questions. You can verify it here only. If I talk about the expansion written above, a plus b to the power 5. What is the, let me say, okay, fourth term from the beginning? Tell me. It's very simple. See, this is your term 1, this is your term 2, this is your term 3, this is your term 4, this is your term 5, and this is your term 6. So your index was 5, number of terms is 6. I am saying fourth term from the beginning, which is this one. What is this? This is equal to, let me write, 5c3a to the power 2, b to the power 3. Fourth term from the beginning is which term from the end? By just looking at it, you can say it's third term from the end. So from the end, when you start counting, it's the third term. From the end, it's the third term. So it's third term from the end. But how do you arrive at this? You arrive at this by saying n. N means 5, k means 4 plus 2. That means 5 minus 4, 1, 1 plus 2, 3. So third term from the end. That's how you can verify. Quickly check. Quickly check. Everybody, quickly check. Is this clear? Is this clear? Fourth term from the beginning will be n minus k plus 2th term from the end. That means 5 minus 4 plus 2th term from the end. That means third term from the end. You can verify, you can cross check because the expansion is written right above my head. Count the fourth term from the beginning. It is the same as the third term from the end. Isn't it? This formula is verified, it's checked. Is everything hashtag HDCC till here? High definition, crystal clear, people. I am moving ahead to the general term because after this, I will be bombarding questions on you and you have to answer those questions as fast as possible, as accurately as possible. General term, people, you are already aware of it. When you say your a plus b to the power n is nothing but summation NCR a to the power n minus r, b to the power r going from 0 to n. This term is what is called your general term. And needless to say, the first term looks like NC0, a to the power n minus 0, b to the power 0. Second term looks like NC1, a to the power n minus 1, b to the power 1. Third term looks like NC2, a to the power n minus 2, b to the power 2. That means what? First term has NC0. Second term has NC1. Third term has NC2 and so on. So NCR, that means going to sit with R plus 1th term. That's the feel. Did you feel it? Did you feel it? R plus 1th term is what is going to look like NCR, a to the power n minus r, b to the power r. Is this clear, folks? Is this clear? What is the major mistake which students commit when you say R plus 1th term? They kind of write NCR plus 1. Or when you say Rth term, they write NCR. No. No. This and this do not match. This is wrong. It's a reflex. It's a very intuitive exercise which students kind of by mistake enter into. It's not their fault. But this should be felt by you, not just understood by you. It should be felt by you. Absolutely correct. Actually, fourth term's coefficient from beginning is equal to third term's coefficient from the end. Yes, Yash, that's what I said. I'm not saying the terms are matching. I am not saying the terms are going to match. I'm just saying the coefficients are going to match. Of what? First term from the beginning, first term from the end. Second term from the beginning, second term from the end. Third term from the beginning, third term from the end. The binomial coefficients of these terms are going to match. I'm not saying the terms itself are going to be identical. Their binomial coefficients are going to be identical because NCR is same as NCN minus R. Is this clear? Is this clear? All righty then, let's move ahead. This is your general term. This is your general term. Now tell me, this is question number 1. What do you think is summation NCR 5 to the power R? What do you think is this answer? Please answer. What is this? This kind of doesn't resemble the generic standard setup that summation NCR e to the power n minus r b to the power r. Doesn't resemble it directly. What is this equal to? Alka, Yash, tell me quickly. Arul, quickly tell me. What is this equal to? What is this equal to? Tell me. What is this equal to? Absolutely correct. Bang on. Yeah, bang on. I'm super impressed. What is this equal to? Summation NCR. Look at this. Summation NCR 1 to the power n minus r, 5 to the power r going from 0 to n. This is how you modify. And hence this comes out to be 1 plus 5 whole to the power n, which means 6 to the power n. Is this clear? This should be clear. You don't have an option. This should be clear. When you look at this expression, 100% this manipulation should pop up in your head right away. Next up is this. Slight modification. Summation minus 1 to the power r, NCR 1 by 3 to the power r. See guys, we are brainstorming. We are working on our brain. We are exercising. We are grilling it, training it, increasing its stamina. That's what we need right now. Summation minus 1 to the power r, NCR 1 by 3 to the power r. What do you think is the answer? Yes, you're correct. You're correct. What is the answer? Quick. Quick. Anybody? Any clue? Any guess? What is this equal to? What is this equal to? I can write this as NCR 1 to the power n minus r minus 1 by 3 to the power r going from 0 to n. Can I write it like this? Can I write it like this? Yes. Again, this is equal to what? 1 minus 1 by 3 to the power n, which means 2 by 3 to the power n. Bingo. Yes, you are correct. Bang on, high five. This is when you say that, ma'am, I have understood the binomial theorem. I know how it behaves. I know how to manipulate. I know what actually it says. When you know what it represents, what it stands for, any little bit here and there I tweak, you will be able to crack it. 100%. That's why I've taken this much time for you to just feel the binomial theorem, absorb it, because now I am going to dive into the questions. But before that, here is a PYQ. And questions like these have been asked again and again and again. They were asked in advance, and now the pattern has been repeated in mains as well. Tell me, what will you do here? It says find the sum of this series up to m terms. Now, m can be anything up to 5 terms, up to 10 terms, up to 20 terms, 50 terms. This m is something which can be replaced with any fixed number when this question comes in your exam. But right now, tell me the approach. Tell me the approach. It's a very important high weightage PYQ. What is it? What will you do? Summation minus 1 to the power r, NCR 1 by 2 to the power r, plus summation minus 1 to the power r, NCR 3 by 4 to the power r, plus summation minus 1 to the power r, NCR 7 by 8 to the power r, plus and so on. R is varying from 0 to n, which is our original standard requirement. Any confusion? This is the trick. Now you know what is this equal to. This is 1 minus 1 by 2 whole to the power n plus 1 minus 3 by 4 whole to the power n. I just taught you on the last slide. Plus 1 minus 7 by 8 whole to the power n plus and so on. Fantastic. This is good. This is pretty cool. So this gives me 1 by 2 to the power n. This is 1 by 4 to the power n. This is 1 by 8 to the power n plus and so on up to m terms. Now is it simple? Now is it easy peasy lemon squeezy? Yes, no? Because now it's representing a GP of m terms, everybody. Now it's representing nothing but a GP of m terms. What is the common ratio, everyone? Tell me. 1 upon 2 to the power n. So this is what r to the power n minus 1 upon r minus 1, right? So 1 upon 2 to the power n to the power m minus 1 upon 2 to the power n minus 1. R to the power n minus 1 upon r minus 1. Is this clear? Yes, no? And if you feel 1 by 2 is a fraction, hence it has to be less than 1, we can apply the formula in the reverse manner. 1 minus r to the power n upon 1 minus r. 1 minus r to the power number of terms upon 1 minus r. Any confusion? You can simplify this. This is your final answer. Thumbs up. Hashtag HDCC. Is this question hashtag Bhoomified? Is this question hashtag Bhoomified? The connection between the question and you, has it been smoothly established? Perfectly connected? Yup. Cool. I can move ahead. I hope now you have absorbed nicely. What does the binomial expansion say? What are its properties? What are its associated alternate versions in which I can tweak and present it to you? And accordingly, you can get this tweaked version as a question also. This little bit shifted version as a question also. So don't be scared. Don't be scared at all. Let's go. Let's go then and talk about one last thing. One last thing, which is this, after which I present to you plethora of questions. Plethora of questions. What is this equal to? X plus y to the power n is nc0, x to the power n, y to the power 0. Then nc1, x to the power n minus 1, y to the power 1. Then nc2, x to the power n minus 2, y to the power 2, plus and so on. And x minus y to the power n is nc0, x to the power n, y to the power 0, minus nc1, x to the power n minus 1, y to the power 1, plus nc2, x to the power n minus 2, y to the power 2, and so on. So when you add these two, obviously this gets cancelled, and so on. What are you left with? The even lower indices. You're left with terms having even lower indices, that too 2 times. So what is the answer here? The answer here is twice of nc0 x to the power n plus nc2 x to the power n minus 2 y to the power 2 plus nc4 x to the power n minus 4 y to the power 4 plus and so on. Basically the even subscripts or the odd terms, terms sitting at odd positions, first term, third term, fifth term, seventh term, and so on. That's what you are getting 2 times when you add these two expansions. Or how can you remember it as? The even subscripts. The even subscripts is what you land up with. And when you subtract, what happens? Opposite happens. You're left with twice of odd subscripts. So nc1 x to the power n minus 1 y to the power 1 plus nc3 x to the power n minus 3 y to the power 3 and so on. Because it's but obvious, see, when I will subtract, this will become plus, this will become minus, this will become plus. So this will get cancelled out. You'll be left with 2 times nc1, then nc3, then nc5 and so on. Yes. Is this cool? Is this cool? This doesn't get used way too much. Whenever it gets used, I think it's very intuitive for you to realize even then in that question, how should we proceed if such an expansion occurs? Is it cool, people? Okay then. Come here. Tell me. What do you think is the answer? How do you think you will proceed with this? Come on, come on, come on. Think. How do you think you will proceed with this? If the coefficient of x to the power 10 in this binomial expansion is 5 to the power k times L, where L and k belong to set of naturals and L is co-prime to 5, what is k equal to? Beautiful question, very important, highly voluminous, must solve for JEE Main, must solve. Now, first of all, please realize, when you say L is co-prime to 5, what do you mean? When you say L is co-prime to 5, what do you mean? That means the HCF of L and 5 is equal to 1. What does it mean? HCF of ln5 is equal to 1. And when you say HCF of ln5 is equal to 1, it means there are no 5s present in L. L doesn't have any 5. 5 is not a factor of L. L is not a multiple of 5. There is no 5 in L. There is no 5 in L. Absolutely correct? Yup. Now, coefficient of x to the power 10 in this expansion. What will you do to start this question? Obviously, you will write the general term. You will get 60 CR x to the power 1 by 2, 5 to the power minus 1 by 4 raised to the power 60 minus r, 5 to the power 1 by 2 x to the power minus 1 by 3 raised to the power r, where r is greater than equal to 0, less than equal to 60. This much I feel is absolutely understood. Any doubt, anyone? Stop me right here, right now, if there is any doubt. Anyone? Just written the general term. I've not done anything else. I've not done anything else. Yep. Cool? Cool? Chalo. This gives me 60 CR, 5 to the power r minus 60 upon 4, 5 to the power r by 2, x to the power 60 minus r by 2, x to the power minus r by 3. So you are going to get 60 CR, 5 to the power r by 4 minus 15 plus r by 2, x to the power, this will give you 60 minus r by 2 minus r by 3. So 30 minus r by 2 minus r by 3. Just simplify. Please solve. Everybody pick up your pens and notebooks and solve. What are you getting? You will get r by 4 plus r by 2 is 3r by 4. So you are getting 60 CR 5 to the power 3r by 4 minus 15 x to the power. Tell me. What is this? This is 30 minus r by 2 plus r by 3. 5r by 6. So this is 30 minus 5r by 6. This is how you have to simplify till the time you don't get your constant part, and this is the variable part. Mind it, guys, this is the constant part and this is the variable part. Now you want x to the power 10, the coefficient of x to the power 10. Yes or no? Coefficient of x to the power 10, that means this portion you want to be equal to 10. Isn't it? Isn't it, people? Making sense? So 30 minus 5r by 6 is 10. So 20 is equal to 5r by 6. R is coming out to be 24. Is this what you are getting? Are you getting R as 24? Are you getting R as 24? Very good, Alka. If R is 24, that means 25th term has x to the power 10. That means 25th term has x to the power 10. Okay, and how will it look like? It will look like 60C24. Yes, 5 to the power 3 into 24 by 4. So 4 into 6, 18 minus 15 is 3. 5 to the power 3 and x to the power 10. This is the term having x to the power 10, or rather, this is the coefficient of x to the power 10 in my given expansion, which was given equal to 5 to the power k times L. Now, a blunder which students commit. They write 5 to the power 3 into 60C24. This coefficient is given to be equal to 5 to the power k times L. They straight away compare this with this and report their answer k to be 3. How many of y'all think this is the right approach? How many of y'all think this is the right approach? Direct comparison, report your answer as 3. How many of y'all think this is the right approach? Tell me. How many of y'all think this is the right approach? Any clue, anybody? Is this the right approach? Is this the right approach? It's not. It's not, because when you said 5 to the power k times L, there are no 5s present in L. So k is the maximum power of 5 on the right hand side. You are not able to extract any more 5s from L. But on the left hand side, we don't know yet that 60C24 has some 5s and power of 5s present in it or not? Are you able to realize the criticality of this situation? How critical is this situation? We have to find out how many 5s are sitting inside 60C24. Okay, how many 5s are sitting inside 60C24, for which we are going to use a brand new concept. Not that new, but I should say a beautiful concept. If you remember from PNC, what is the concept? Everyone please tell me. Quickly tell me. It is exponent of 5, which is a prime number. Let me write the formula. Exponent, yes, you are correct. Exponent of p in n factorial. So when you write n factorial, n is a natural number, you open it up. Inside that expansion, inside that expression, the prime power p comes with what index, what degree is what this formula gives you. It is equal to n upon p GIF plus n upon p square GIF plus n upon p cube GIF plus and so on till the time you get 0. Once you get a 0, after that everything will be a 0. So here what I'm going to do is, how I'm going to use this is 5 is a prime number. You want what? How many 5s are sitting in 60C24? See, 60C24 is nothing but 60 factorial, 24 factorial and 40 factorial. So we are going to find powers of 5 in each of these factorials. So I'm going to write exponent of 5 in 60 factorial. Then I need exponent of 5 in 36 factorial. Then I need exponent of 5 in 24 factorial. Yes, ma'am. No, ma'am. Yup. Correct. What is this? 60 by 5 GIF. 60 by 5 square GIF. Then 5 cube onwards, everything is going to be 0. So I'm not going to write any ahead. What is this? 12 plus 2, that is 14. Next, this is 36 by 5 GIF, 36 by 5 square GIF, plus and so on. Everything else will be a 0. So you are going to get 7 plus 1, that is 8. Up next, we have 24 by 5 GIF. 24 by 25 will give you 0 point something. GIF will be 0. So no need of writing anything ahead. This is what? 4. That's it. This means what? This means what? Please understand. It's very interesting. It's very, very interesting. This means what? Inside 60 factorial, you have 5 to the power 14 and something multiplied with something which does not have 5. Upon 24 factorial has 4 powers of 5 into something which doesn't involve 5. 40 factorial. This 40 factorial or 36? Oh, this is 36. This has to be 36. Now 36 factorial has 8 powers of 5. So 5 to the power 8 into something which doesn't have 5. So eventually in 60C24, you are going to get what? 8, 9, 10, 11, 12. That means 2 powers will be left. 5 square into something which doesn't involve 5. In 60C24, there are exactly 2 5s present. In 60C24, there are exactly 2 5s present. In 60C24, there are exactly 2 5s present. Is this clear? Is this clear? Yes, ma'am. Now I'm in a position to go back and say that no k equal to 3 is not the answer. Eventually, what will you do? You will write 5 to the power 3 into 60C24 will be 5 square into something which doesn't involve 5 is equal to 5 to the power k into L, where L is something which doesn't involve 5. So now you can do a straight away comparison. This will give you 5 to the power 5 into no 5 equal to 5 to the power k into L. L has no 5. Now you can compare and your k will come out to be 5. Is this clear? First question, nuclear bomb question. Is this clear? I am not going to spoon feed you, bache. If you feel I'm going to spoon feed you at this point in time when we are so close to our exams, that's not me. That's not me. I will explain you each step. I will deep dive into the concept. I will unlayer it for you. I will do a post-mortem, detailed post-mortem of the question, so that with this much questions, you can get this much content. That's what is the need of the hour. Okay? Okay? Yup. Let's go ahead then. Is this question hashtag HDCC? Is this question completely boomified? Is this question completely boomified, people? Any doubt? Anyone stop me right now? Perfect. Alka, this is the topic of 11th, so great job done. Chalo. Look here. Coefficient of x to the power minus 1 and x to the power minus 3 in this expansion are m and n. If r is a positive integer such that mn square is 15cr into 2 to the power r, what is the value of r equal to? Perfecto. Good job done. Tell me quickly. See, the previous question is kind of implying that questions are asking for multi-concept involvement. The questions are going to be multi-conceptual, people. Binomial is going to involve concepts of determinant, of PNC, of whatnot, of quadratic, of everything. And that is why completing the syllabus is so important, but in a smart manner, right? We will be putting in the hard work, but in a smart manner. And that is what I am here to do for you. So let's go. Let's go, everyone. Coefficient of x to the power minus 1, x to the power minus 3 in this expansion. Look at the expansion. 2x to the power 1 by 5 minus 1 upon x to the power 1 by 5 whole to the power 15, x is positive. So write it down. Write the general term. This is 15cr, 2x to the power 1 by 5 whole to the power 15 minus r minus x to the power minus 1 by 5 whole to the power r. R is running from 0 to 15. Tell me, is this clear? Is this clear? You're going to get 15cr 2 to the power 15 minus r minus 1 to the power r. X to the power 15 minus r upon 5 and x to the power minus r by 5. Yup, this is 15cr 2 to the power 15 minus r minus 1 to the power r. X to the power, this is 3 minus r by 5 minus r by 5. So 3 minus 2r by 5. What do you need? You need coefficient of, now this is the constant part. Always your endeavor, your effort should be to segregate the constant part, segregate the variable part. And this is your variable part. Now you need x to the power minus 1. So let's start. When this power 3 minus 2r by 5 is equal to minus 1, what are you getting? What are you getting? 3 plus 1, 4 is equal to 2r by 5. 5 into 4, 20. This implies r is 10. And when you are wanting 3 minus 2r by 5 is equal to minus 3. So 3 plus 3, 6 is equal to 2r by 5. This is 30, r is 15. Please tell me. Any confusion, any doubt till here? When you say r is 10, that means 11th term has x to the power minus 1. When you say r is 15, that means 16th term has x to the power minus 3. Am I making sense? Am I making sense? It says coefficient of these two, b, m and n. So I have to compute the 11th term and the 16th term. 11th term and the 16th term. Okay? 11th term will be what? 15c10, 15c10, 2 to the power 15 minus 10, which is 5, and x to the power minus 1. Yup. Similarly, 15c15, yup, 2 to the power 15 minus 15, which is 2 to the power 0, x to the power minus 3. Easy peasy? Is this easy peasy? There is a minus 1 raised to the power r as well. So minus 1 raised to the power 10 is 1, minus 1 raised to the power 15 is minus 1. So this you can write as 15c5, 2 to the power 5, x to the power minus 1, and this you can write as minus, that's it, minus x to the power minus 3. So when it says coefficients are m and n, this is your m, people, and minus 1 is what is your n. That's it. So when you say mn square is 15cr 2 to the power r, mn square, n square is 1 only, minus 1 square is 1. M means 15c5, 2 to the power 5 is 15cr, 2 to the power r. R is nothing but 5. Bingo, that's your answer. Please check this. Check this out. Tell me any confusion in the calculation, any confusion in any part, any confusion in understanding what the statement of the question is trying to say. See, first of all, you have to read the statement carefully, interpret its meaning, try to recollect, okay, is it matching with some concept? And then pick up your pen and start writing. Start writing in a crazy manner because you know it. You know the concept. All you need to do is match the following. What do I mean by match the following? Match the question statement with the concept in your head. Once that match is done, once that Wi-Fi connection is done, once that hashtag Bhoomified is done, then you pick up your pen and start writing. It will go in the right direction for sure. 5 is the answer. Absolutely correct, everybody. Let's jump on to the next question. And this is what we have next in store. Coefficient of x to the power 18 in the product. Tell me what is this? 1 second. Yup. Tell me what is it? The coefficient of x to the power 18. Coefficient of x to the power 18 in this product. How are you going to proceed? Yes. Think hard. Think hard. Come on, come on, come on, come on, brainstorm. Come on, I want people to come up with different approaches. Quickly tell me, how are you going to proceed with this question? Coefficient of x to the power 18 in this product. Tell me. Okay, there are two approaches. There are two approaches. Yes, you are correct, Samrat. Yes, Alka, even you are correct. See, what is approach number 1? What is approach number 2? So when I say M1, both of them will land you up with the same expression. But look here. I can do this. See, 1 plus x, 1 minus x to the power 9, 1 minus x to the power 1. So I have segregated the power 10 as 9 plus 1. Smart trick. Direct trick. Why did I do this? Because further next I had a factor 1 plus x squared to the power 9. So this is linear, this is binomial expansion, this is multinomial expansion. A linear polynomial multiplied with a binomial expansion multiplied with a multinomial expansion. So what did I do? That multinomial had power 9 and binomial had power 10. So I segregated it, broke it up as 9 plus 1. Now, how is it useful? What is this? A minus b, a square plus ab plus b square, which is a cube minus b cube. So you will get 1 plus x, 1 minus x. Yes or no? Right here 1 and right here 9. Yep. These both combine as a cube minus b cube to the power 9. Yep. So 1 plus x into 1 minus x, a cube minus b cube. So this is a square minus b square, a cube minus b cube to the power 9. Am I making sense? Everybody please tell me, am I making sense? Yes, third term in cube lord, you are absolutely correct. Absolutely correct. Okay, method 2. Something which you can remember as a generic approach whenever you have all these mixed type of expressions being multiplied from within which you have to compute the coefficient. So you are getting 1 plus x, 1 minus x to the power 10, and this is a GP. Remember, 1 plus x square. Remember or not? 1 plus x square is a GP, people. This is a GP of 3 terms with common ratio equal to x. So this will look like a 1 minus r to the power n upon 1 minus r. All of this to the power 9. So how will you simplify this? You have 1 plus x. You have 1 minus x to the power 10. Next you have 1 minus x cubed to the power 9 upon 1 minus x to the power 9. So this gets cancelled, this gets cancelled. You are left with the exact same expression, a square minus b square into 1 minus x cubed to the power 9. Please check this. Please check this. Two methods, landing you with the same answer, landing you with the same expression on which now finally you have to proceed further. Beat method 1, beat method 2. Beat method 1, beat very soon, Anushri. Fingers crossed. Very, 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 very soon. But right now, please cooperate, bache. See, whatever you say, whatever you ask us to do for your comfort, that's our first priority. If you ask us that, ma'am, take sessions on boards, that's our first priority, that we want to provide you with utmost comfort to make this transfer of knowledge super easy, super convenient, super smooth for you. But there are certain glitches which come in between, certain things which are not in our control. And that is where we want your cooperation. That is where we want your support. Because there is no discount on the hard work which a teacher does, no matter if she teaches on the board or she teaches here in this setup. There is no difference in the hard work. Trust me. The only thing is board makes you feel larger than life. This, I understand, doesn't give you that feeling. But please cooperate. Very, very soon it's going to happen, because that is at the top of my head, at the top of everybody's head. Alrighty. Thank you so much. Can you repeat method 1? Method 1 was, you have 1 minus x to the power 10. 10 you write as 9 plus 1. So 1 power you write separately, 9 powers you write separately, and that 9 power wala 1 minus x, you adjoin, you combine with 1 plus x square to the power 9. So what will you get? You will get 1 minus x to the power 9 and 1 plus x square to the power 9. Okay, so this is 1 minus x into 1 plus x square whole to the power 9. This is a minus b into a square plus ab plus b square. A cube minus b cube. So 1 cube minus x cube whole to the power 9. Is this clear? Yes, that's very, very correct, Samrat. If you are getting in-depth concepts, doesn't matter, it's coming from the board or coming from the vacuum. As long as the concepts are deep, it's clear, that's what matters. All right? Critical questions important. I'm going to cover it all, Ashwin. This is what the agenda is, bache. Because you are so close to your exams, I have done so much of hard work in collecting these questions for you, which will convey all possible results and varieties which can be asked from this chapter. So you can completely blindly rely on this session is what I can vouch for. Just rely on it, depend on it completely, absorb it as it is. ठीक है? Chalo. Now let's go ahead. A square minus b square, 1 minus x cube whole to the power 9. Now what will you do? 1 multiplied with this binomial, x square multiplied with this binomial. You will get 1 minus x cube to the power 9 minus x square into 1 minus x cube whole to the power 9. Yup, it's enough. Ashwin, it's more than enough. Don't overwhelm yourself, bache. It's more than enough. Chalo, from here I want coefficient of x ki power 18, and from here this expression as well. So this is one complete binomial. General term will look like 9cr 1 to the power 9 minus r minus x cube to the power r. That means 9cr minus 1 to the power r x to the power 3r, where r is running from 0 to 9. This is clear? This is clear? And from here, x square is already sitting outside. From inside, what do I need? What do I need? I need coefficient of x to the power 18 overall, right? So look here. Please look here. How will a general term in this expansion look like? 9cr 1 to the power 9 minus r minus x cube to the power r and x square as it is. So it will look like 9cr minus 1 to the power r x to the power 3r plus 2, where again your r is varying from 0 to 9. Alrighty. Okie dokie. I want x to the power 18 ka coefficient. So this I want to be 18. 3r equal to 18 implies r equal to 6. So from here I've got the coefficient 9c6 minus 1 to the power 6 is 1. From here I again want x to the power 18 ka coefficient. So 3r plus 2 equal to 18, 3r equal to 16, r equal to 16 by 3 doesn't belong to the set of whole numbers. This does not belong to the set of whole numbers, and R has a compulsion attached to it. It should come from the family of whole numbers. It is not allowed to be a fraction. That means there is no valid whole number sandwiched between 0 and 9 for which you will get x to the power 18. That means from this expansion, you are not getting any term having x to the power 18, or I can say the coefficient of x to the power 18 from this second expansion is actually 0. The coefficient of x to the power 18 from the second expansion is 0. The only valid acceptable coefficient is 9c6, which is same as 9c3. Because NCR is same as NCN minus R. Yup. This is what 9 factorial upon 3 factorial, 6 factorial. A shortcut here as well. I'm going to give you tremendously many shortcuts. When you say 9c3, write 9 into 8 into 7. Just write it as a product of preceding terms till 3 quantities, because niche there is 3 factorial. 9 into 8 into 7 upon 3 factorial, which is 6. What are you getting? 3 into 3, and this is 2 into 4. This is 84. 84 is your answer. Yes? This is the depth to which you have to analyze every question. You have to analyze these questions in these depths, bache, because see, if you analyze the past trends, the previous year papers, you will realize that, okay, questions might not be ditto photocopied. Many a times even that is the case. But the concepts, the ideas, the formulas, the flow, the approach, they are definitely repeating again and again and again and again, so much that now it's more or less predictable. Trust me, standing here teaching for so many years, I can literally tell you it's predictable. And that is why when I collect questions to share with you, even when I take PYQs or some new questions, some advanced level questions, the idea is to share with you the concepts which are supremely high weightage and are at the top priority for the JEE Main examiners to give in your exam. Getting my point? Now, let's get ahead and talk about the next question. I hope the variety you are appreciating and writing everything in your notebook in a very clear manner. Let's go. This is very simple. This is very, very simple. Yes, you are correct, Samrat. I am not at all denying what you're saying. Absolutely correct. Calculations is where the major problem occurs. If the coefficient of x to the power 3 and x to the power 4 in this expansion, in the powers of x are both 0, can you do this question on your own? Let me give you a hint. I think this question you can very easily do by yourself. See, it's written 1 plus ax plus bx square, all of this multiplied with 1 minus 2x to the power 18. Please listen to me carefully. This is kind of resembling the setup of the previous question. How? You had a quadratic 1 minus x square multiplied with a binomial. So every term of that quadratic you actually multiplied with the binomial expansion, so that you got many different binomial expansions. Then you computed coefficient from each expansion and towards the end reported your answer. Here also same thing is happening. You have a quadratic and you have a binomial. Now binomial you can't open. It's a super long expression, that to power 18. That means when you open it up, it will have 19 terms. Oh my God, 19 terms. Rather, what you do, 1 multiplied with this binomial, ax multiplied with this binomial, bx square multiplied with this binomial. You will get 3 binomials. Treat each one of them separately, obviously, and compute the answer corresponding to each one of them. In the end, add or subtract as the question demands. So, you will get 1 into 1 minus 2x to the power 18 plus ax into 1 minus 2x to the power 18 here also. Any doubt, anyone? Look here. Cool? All perfect? Now, you want coefficient of x to the power 3 and x to the power 4 from each of these expansions. And the coefficient's value, when you eventually compute the coefficient, the value is 0. So, look here. General term will look like 18cr, 1 to the power 18 minus r, minus 2 to the power r, x to the power r. Here, r is varying from 0 to 18. Alrighty. Next. General term will look like what? 18cr. A is as it is. 1 to the power 18 minus r minus 2 to the power r, x to the power r plus 1, because there is one more x sitting outside. Here also r is varying from 0 to 18. Cool. Next, b as it is, NCR, 1 to the power n minus r minus 2 to the power r, x to the power r plus 2. Again, r varying from 0 to 18. That's it, people. This was the only tricky step. This was the only critical step. Now, all you need is x to the power 3 ka coefficient, x to the power 4 ka coefficient. So, x to the power 3 ka coefficient from here will be 18C3 minus 2 to the power 3. From here, r plus 1 equal to 3 means r equal to 2. So, you will get a 18C2 minus 2 to the power 2. From here, r plus 2 equal to 3 means r equal to 1. So, b NC1, not NC1, 18C1 minus 2 to the power 1. This represents coefficient of x to the power 3, which is 0. Similarly, you want coefficient of x to the power 4. Okay, coefficient of x to the power 4. What will that come out to be? Again, coefficient of x to the power 4. R4 means 18, C4 minus 2 to the power 4 plus a. When you say r plus 1 equal to 4 means r is 3. So, a times 18C3 minus 2 to the power 3. Next, you want r plus 2 to be equal to 4. That means r is 2. So, b times 18C2 minus 2 to the power 2. This is also 0. Ashwin, little bit of functions required, but don't worry. You can see how I teach. I teach by unlayering every concept, by actually extracting every little idea which is used in the question from whichever chapter. I actually do the postmortem so that you get quality practice, which means even when you solve 50 questions, you get the knowledge of 500 questions. That's why I call my session a one shot with too much power, with too much confidence. Okay? Not every one shot is actually a one shot. All right, perfect. That's okay. That's okay. You can join after 6, Anushri. It's okay. It's okay. So all you have to do is simplify this, simplify this. You will have two equations in two variables a and b, compute a and b and report a comma b. Is that cool? Is that cool? Can you do this much? Is that cool? Can you do this much, people? Any doubt? Anyone? Please tell me right now. Is this question hashtag HDCC? Is this completely boomified? I want you all to tell me, is this hashtag boomified? Is this hashtag high definition crystal clear? You have two equations in two variables a and b. You can very easily use the elimination method or substitution method. Compute a and b. Your answer is option D. Yup. Cool. Cool then. Let's go ahead. Let's go ahead talk about this question. Here I will be revealing a bomb concept. How many of y'all know the shortcut of computing ratio of the fifth term from the beginning or rth term from the beginning and rth term from the end? There is a shortcut. There is a shortcut. Everything will happen, Anushri. Very soon I will share with you a detailed schedule. Right now we are only sharing the schedule of 1 week at a time. But in a few days, we'll share the entire month's schedule. From January onwards, the sessions are going to get accelerated, focusing towards your marathon sessions, too much question practice, PYQ practice, formula sheets, too much of tricks and tips. So the direction is going to be too much towards the exam, but everything, the schedule is going to be shared with you very soon. Don't worry about it. Right now, please focus on this session. Ratio of the fifth term from the beginning to the fifth term from the end in this expansion is what? How many of y'all know? How many of y'all know what is the formula? What is the shortcut? Okay, Ashwin. Okay. Tell me. And don't worry, even if we go by the sequence, not by the sequence, because right now we are very much close to the exam, whatever prerequisites you will need from whichever chapter, I'll tell you. Please don't worry, bache. Please don't worry. This is the best way you can revise your syllabus and make yourself exam ready. No doubts about it. Tell me, do you know the shortcut? This is a killer shortcut, people. When you say rth term from the beginning, Suppose you have the expansion a plus b to the power n. This is your expansion. Mind it, this is your expansion. You are saying rth term from the beginning upon rth term from the end. What is this shortcut for? Rth term from the beginning upon rth term from the end. Remember what I told you? Remember, rth term from the beginning is this. Rth term from the end is n minus r plus 2th term from the beginning. Rth term from the beginning is tr and rth term from the end is actually n minus r plus 2th term from the beginning. I told you this result. Very important. Now what is this? This is tr minus 1 plus 1 and this is t n minus r plus 1 plus 1. Deliberately I have to write this subscript as something plus 1 because I know tr plus 1 is ncr a to the power n minus r b to the power r. So the lower index should look like something plus 1, something plus 1, something plus 1. Yes? Very soon we'll be coming up with EAP CET exam question discussion as well. Thorough practice waiting in store for you. Too much is being planned. Okay, let me not reveal everything. Focus on the now. Here, come here now. T, r minus 1 plus 1. This will give you n c r minus 1 a to the power n minus r plus 1 b to the power r minus 1 upon n c n minus r plus 1 a to the power r minus 1 b to the power n minus r plus 1. Now, you know, as a matter of fact, NCR is same as NCN minus R, and hence this and this gets cancelled out. It's the same quantity. Photocopy upar niche. NCR is same as NCN minus R. This will give you what? A to the power n minus R minus plus 1 plus 1. So, n minus 2R plus 2 upon B n minus 2R plus 2. Please tell me if you're getting this. So, you are getting a by b to the power n minus 2r plus 2. Yes, sir. Is this cool? This is your shortcut. Always remember, this is a must remember. Must remember. Rth term from the beginning upon Rth term from the end. This shortcut is very useful, very important for all the exams that you're going to sit for. It's a real time saver. I have shared with you the proof. You don't have to do the proof again and again. Just remember the result. A by b. The expansion was a plus b to the power n. The result is a by b n minus 2r plus 2. A by b n minus 2r plus 2. And the same thing gets applied here. Fifth term from the beginning, fifth term from the end. So r is 5, n is 10. Right? This is your A and this is your B. A by B, 2 to the power 1 by 3 upon 1 upon 2 into 2 to the power 1 by 3. A by B to the power n minus 2r plus 2. N is nothing but 10. So you are getting 2 to the power 1 by 3 into 2 to the power 1 by 3. All of this 10 minus 10 gaya. This is 2. So you are getting 2 square and 2 to the power 2 by 3 plus 2 by 3. This is 4 by 3. So this is 4 into 16 to the power 1 by 3. No, 32. 2 to the 4 to the 16 to the 32. Please tell me. Huh. Quickly. This is such a 3 to the power 1 by 3. Okay, my bad. This is 3 to the power 1 by 3. Okay. Little change in the question, 3 to the power 1 by 3. Okay. Not a problem at all. Just a little tweak in the numbers. 2 square, 2 to the power 1 by 3, 3 to the power 1 by 3. So 6 to the power 2 by 3. So this is 4 into 36 to the power 1 by 3 upon 1. And that's your answer. That's your answer, people. See. That's your answer. That is it. Easy peasy lemon squeezy. Is this cool? Just remember the shortcut. You get direct question. This is a PYQ. You get direct questions involving the shortcut. Please save your time, bache. Do not fall in the long method. That fifth term from the beginning. See, understand, this has 11 terms. You will have term 1, term 2, term 3, and so on. Term 11. Fifth term from the beginning is okay, term 5. Fifth term from the end, if you start counting 11, 10, 9, 8, 7. Seventh term will be the fifth term from the end. So actually you have to compute term 5 upon term 7. This is what you have to compute. Okay, so you can write term 5 as NC4, a to the power n minus 4, b to the power 4, and write term 7 as NC6, a to the power n minus 6, b to the power 6. Then cancel out, simplify, solve, get the same answer. Okay, so you can do this long method or you can use the shortcut. Cool? Let's go. Let's go and tell me this. This is a beautiful question. Very interesting. Very interesting, very brainstorming. This is a 99 percentiler question. Tell me, guys, I'm challenging you. I'm challenging you. I am challenging you. Can you solve this question? If the number of integral terms in this expansion is exactly 33, what is the least value of n? Hi Shreya, welcome to the class. See, I'll also tell you, if you are able to crack a question, write hashtag Bhoomified. If you understood the question clearly, write hashtag HDCC, high definition crystal clear. Tell me now, if the number of integral terms in this expansion is exactly 33, what is the least value of n? Number of integral terms, number of rational terms. This is a variety of question which is asked tremendously in JEE Main. Like there is flood of these type of questions in JEE Main, actual flood. And the way, the method, the approach is the same. It's the same old school conventional GCPT approach, which is what I'm going to share with you. Yes, Anushri is asking how to approach. I'm going to share with you the approach which gets universally applied in any question that demands from you integral terms, rational terms, irrational terms. It's the same. Now look here. Please look here. Write the general term. Write the general term. It will look like NCR 3 to the power 1 by 2 to the power n minus r, 5 to the power 1 by 8 to the power r. Yep. This is cool. This is cool. Remember, r is varying from 0 to n. n I don't know. NCR 3 to the power n minus r by 2. That means n by 2 minus r by 2. 5 to the power r by 8. Now listen to me very carefully. Listen to me very carefully, guys. Your ears should pop open. Leave your pens. All focus on the screen. I don't say this too often. Right now I'm saying this. Listen to me. You want integral terms. You already know your NCR is always a natural number. Your NCR is always a natural number, which means it's an integer. So NCR is a safe quantity. Not at all problematic, not at all going to cause any trouble. If I talk about 3 to the power something, this power should turn out to be a whole number. Until and unless this power is a whole number, I cannot talk about this quantity being natural or being integral. So if I want it to be integral, the power should be a whole number. Similarly, if I want this quantity to be integral, this power should be a whole number. Okay, so what is my condition? My condition is n by 2 minus r by 2 should be a whole number and r by 8 should be a whole number. Both these things should hold true. This and this. Which means what? N has to be a multiple of 2, 0, 2, 4, 6, 8 and so on. Then only n by 2 will be a whole number and r also has to be a multiple of 2 so that r by 2 comes out to be a whole number. R also has to be 0, 2, 4, 6, 8 and so on. And r also has to be a multiple of 8. 0, 8, 16, 24 and so on. Filhal, for now, focus on r. R has two conditions attached to it. R should be a multiple of 2 and R should be a multiple of 8. That means R is allowed to be the LCM, multiple of LCM of 2 and 8. K times LCM. That means multiple of the LCM. That means the LCM is what? 8 only. So 0, 8, 16, 24 and so on. These are your acceptable values of R. These are your acceptable values of R. Did you realize what did I do? Did you understand the approach? Hi Radhika, good evening. Did you understand the approach? Yes, Samrat. Bang on correct. Bang on correct. Okay? All cool till here? When you say R can be 0, 8, 16, 24 and so on, that means, look here, when you say R can be 0, 8, 16, 24 and so on, what does this mean? This means corresponding to R equal to 0, 8, 16, 24 and so on, my terms are coming out to be integral. So which terms are coming out to be integral? R equal to 0 means first term is integral. R equal to 8 means ninth term is integral. R equal to 16 means 17th term is integral. R equal to 24 means 25th term is integral and so on. Yup. So in my large expansion, question says there are exactly 33 integral terms. So this is my first integral term, second integral term, third integral term, fourth integral term. What is my last or 33rd integral term? Tell me. In my expansion, listen to me carefully. In my long expansion, the first term in the expansion is integral, after which ninth term is my second integral, after which 17th term is actually my third integral, after which 25th term is my fourth integral. So which term will be my 33rd integral term? In my original expansion, which term will be my 33rd integral term? For that, look at the pattern, no? 1, 9, 17, 25 and so on. 1, 9, 17, 25 and so on. What do you need? What do you need? What do you need? 33rd integral term. 33rd integral term. This is your first integral term, second integral term, third integral term, fourth integral term. I want 33rd integral term. This is your AP, people. This is your AP with first term A and common difference 8. You want the 33rd term of this AP. So A plus n minus 1 times D. So this will be giving you 257. Is this cool? So term 257th. This is your term 257 will be your 33rd integral term. Am I making sense, everybody? Please tell me. Listen to me carefully. In your very large expansion, first term is your first integral term in that expansion. After that, second term, not integral, third term, not integral, fourth, not integral, and so on, eighth, not integral, ninth term is your second integral term. Then third integral term is coming at the 17th position, 17th term. Fourth integral term is at the 25th position. Like that, 33rd and the last integral term, because my expansion should have exactly 33 integral terms, that last 33rd integral term is coming at the 257th position. So I definitely need 257 terms in my expansion, because my 257th term is my last, which is 33rd integral term. Okay, that means in my expansion, I should have at least 257 terms. Yes or no? At least 257 terms. That means what should be the least value of n for which in my expansion I have exactly 33 integral terms? The least value of n should be nothing but bache 256. Because the moment you say, let's say this is A, this is B, the moment you say you have A plus B to the power 256, the expansion will have 257 terms, and the 257th term is your very last 33rd integral term. Yes, you can take n to be greater than 256. In that case also you will have 33 integral terms, but I want least value of n for which you have exactly 33 integral terms. the least value of n. Is this question hashtag HDCC, guys? It's very important, very beautiful, very insightful. This is something which gives joy to someone who enjoys mathematics, who enjoys this chapter, that how exactly are we picturing the situation? You have 30, exactly 33 integral terms, and the 33rd integral term is sitting at the 257th position. That means minimum I can have is 257 terms. So least value of n I can put is n equal to 256, because then the expansion will have one more term, which is 257. That's it. All integral terms exhausted. This is the minimum value of n, 256. Deep, deep, deep. Hashtag HDCC. Yes, no? Yes, no, 256 is your answer. Is this question clear? Also, if the question would have asked how many rational terms, if the question would have asked how many rational terms are there, you would have done exact same thing, because 3 to the power something will be rational when that something is a whole number. So same procedure. Okay, once you have your rational terms, from the total number of terms, which is n plus 1, you remove rational, and what you end up getting is irrational. Total number of terms in the expansion will be n plus 1. Right now you don't have n in this question, but generally you are given n whenever you are asked find the number of irrational terms or rational terms or integral terms. So n plus 1 is the total number of terms. From there you remove rational, you're left with the number of irrational. That's the approach. Are Baba, useful to handsome degree. Wonderful lounging panda. Such innovative names. Okay, come here now. Let the coefficient of the third, fourth, and fifth terms in this expansion be in this ratio. Term independent of x is equal to what? Guys, you know what is term independent of x? Term independent of x means what? What is term independent of x? It simply means x to the power 0. I want the coefficient of x to the power 0. When you say term independent of x, it means coefficient of x to the power 0. That's what you need. Now, coefficient of third, fourth, and fifth term in this expansion. See the expansion? X plus a by x square whole to the power n x non-zero. So, write the general term. NCR x to the power n minus r, a by x square to the power r. NCR x to the power n minus r minus 2r a to the power r. So, n minus 3r. A to the power r. R running from 0 to n. Please tell me if this is clear. Yes, Samrat is correct. X to the power 0. Is this clear? Is this clear? I'm going to write the constant terms together. NCR a to the power r, and this is x to the power n minus 3r. You want coefficient of third term, fourth term, fifth term. See, this is r plus 1th term. When you say third term, that means 2 plus 1th term. What will it be? NC2 a to the power 2. And obviously x to the power 3. No, this is a third term. So n minus 6. You just need the coefficient. You don't need x to the power whatever, but you just need the coefficient. Next is fourth term. Fourth term will be 3 plus 1. So NC3 a to the power 3 x to the power n minus 9. I don't need this x power whatever. Then you have fifth term, which is 4 plus 1. So this is NC4 a to the power 4 x to the power n minus 12. I just need the coefficients, bache. I need what? NC2a square, NC3a cube, NC4a to the power 4. Is this clear? Is this clear? And now magic is going to happen. See, what does it say? Third is to fourth. Third term is to fourth term is to fifth term is what is given to you as 12 is to 8 is to 3. So fourth is to fifth. When I write fourth is to fifth, it's 8 is to 3. Coefficient, this is coefficient. This is coefficient of term 4, coefficient of term 5. Coefficient of term 4 is NC3a cube and NC4a4. I have a smile on my face because are you able to recollect anything? Are you able to recollect a result I taught you right in the beginning, which is the Motu Patlu result or the rich poor result? What did it say? NCR upon NCR minus 1 is n minus r plus 1 whole upon r. It has been asked tremendously many number of times. So here it's written ulta. Here it's written NCR minus 1 upon NCR is r upon n minus r plus 1. That's what you have to realize. So a cube upon a to the power 4 will give you just 1 upon a. But what about NC3 upon NC4? NC3 upon NC4 will give you 4 upon n minus 3. This is 4 upon n minus 3 and all of this has 1 upon a as well is equal to 8 by 3. See this, 4 ones are 4, 4 twos are 8. So a times n minus 3 is equal to 3 by 2. Is this clear? Is this clear? Please check. Please check quickly. Yes, Jevant. Nice. And coefficient of term 3 upon coefficient of term 4 is actually what? 12 by 8, which is 6 by 4, which is 3 by 2. Yup. बढ़े आगे, term 3 coefficient is NC2A square. 4 and 5, 3 and 4, ठीक है. NC3A cube. Exact same pattern. Exact same pattern, बच्चे. NCR minus 1 upon NCR. So this is 3 upon n minus 2. 1 upon a is equal to 3 by 2. This gets cancelled out. N minus 2 times a is equal to 2. So you have two equations in two unknowns. This is 1, this is 2. Two equations in two unknowns. Can you simplify very quickly? Look at this. Two equations in two unknowns. Can you simplify both of them? It's very simple. Two equations in two unknowns, your n will come out to be 6 and a will come out to be half. Easy peasy lemon squeezy. The term independent of x in this expansion is equal to what? Your a is half. You have x plus 1 by 2x squared to the power n is 6. So general term in this expansion will look like 6cr x to the power 6 minus r 2x squared to the power minus r. So you are getting 6cr 2 to the power minus r x to the power 6 minus r minus 2r. So 6 minus 3r. If you want independent of x, that means you want 6 minus 3r to be 0 or 6 equal to 3r or r equal to 2. So you will get 6c2 2 to the power minus 2. Hashtag Bhoomified. Is this Bhoomified or not? Is this Bhoomified or not? Hashtag Bhoomified. This is your answer. Are you getting this as your answer, people? Quickly tell me. Quick, tell me. 6c2 2 to the power minus 2. That's your answer. That's correct, Samrat. See, if you know what the question is demanding from concept perspective, that much if you're able to decode, if that flow is set in your head, then it's all about calculation. But calculation comes into play once when you are moving in the right direction, right? If you are not applying the right concept, then the question of calculation being correct or not is secondary. Yup, true. Okay. All right, let's go to the next question now. Come on. Yup. Well, this time for the next concept. Middle term in the expansion of a plus b to the power n. Guys, before I reveal this, I want to talk about something very important. Can you see this expansion here? Ax plus by whole to the power n. Can you see this expansion here? Ax plus by whole to the power n. Can you see this expansion? Write it, expand it. This is summation NCR ax to the power n minus r by to the power r going from 0 to n. Listen to me very carefully. The critical explanation, this is NCR a to the power n minus r, b to the power r, x to the power n minus r, y to the power r going from 0 to n. Listen to me carefully now, very carefully. This is how each term looks like when you open this summation, right? From here to here is your complete term, the general term of this expansion. But within this term, please understand the terminologies. Alone NCR is what is called the binomial coefficient. Just NCR is what is called the binomial coefficient. If you adjoin the constant part to NCR, which is a to the power something, b to the power something, a and b are constants, then this completely is called the coefficient part. Coefficient part. This, which has variable combined, is called the variable part. And from start to finish, from here to here, is your term. Is this making sense? Is this making sense? I have moved. See, now the screen would be visible to you. I have moved. Look at the expansion. Look at the general term. Please absorb this right now. This completely is the term. From within this, just this part is your binomial coefficient. If you also include the constants, this will represent the coefficient part, and the variable part is just x to the power y to the power. So remove the variable, everything that is left is the coefficient. But from within the coefficient, just NCR is your binomial coefficient. And include everything that is written over here, constant part, variable part, that will represent the term, the general term of the expansion. So all these words you have to be very much well versed with. Term, binomial coefficient, coefficient, variable. Why? Because now, right now, we are going to learn how to compute maximum binomial coefficient. Then we'll move on to maximum coefficient. Then we'll move on to maximum term. Getting my point? So let's start with maximum binomial coefficient. Now I will prove to you that the middle term in any binomial expansion has the largest binomial coefficient. The NCR sitting in the middle term of any expansion has the largest binomial coefficient. That is what I will prove it to you. First of all, let's compute the middle term. If n is even, the number of terms in the expansion is odd. That's very obvious. There will be only one middle term, which is n by 2 plus 1th term. How? See, when you say a plus b to the power 4, your n is 4, which is even. The index is even. This has term 1, term 2, term 3, term 4, and term 5. It has 5 terms. 2 towards the left, 2 towards the right. Obviously, this is the middle term. You can clearly see it's very natural. But how do you reach to the third term? You say your final index was 4 by 2 plus 1th term. N by 2 plus 1th term. Okay, how will it look like? NC, or rather in this example, 4C 4 by 2, A to the power 4 by 2, B to the power 4 by 2. Yes or no? Yes or no? In the general setup, when you have a plus b to the power n, where n is even, your t n by 2 plus 1th term is the middle term. And how does it look like? It look like nc n by 2, a to the power n by 2, b to the power n by 2. The binomial coefficient sitting in the middle term in this case is nc n by 2. Please remember. Please remember. Up next, case 2. When your n is odd, the number of terms in the expansion is n plus 1, which is even. And in that case, there will be two middle terms, n plus 1 by 2th term, n plus 3 by 2th term. How exactly does this work? If you take a plus b to the power 5, let's say, you will have term 1, term 2, term 3, term 4, term 5 and term 6. 2 to the left, 2 to the right, both these are representing the middle terms. That's why you get 2 middle terms. But how do you reach to term 3 and term 4? Well, very, very simple. What is this? This is what? 5 plus 1 by 2. So 5 is your index, plus 1, 6. 6 by 2 will give you 3, third term. And just after that, plus 1. So T 5 plus 1 by 2 plus 1, which is 5 plus 3 by 2. That's why it's written n plus 1 by 2 and n plus 3 by 2. Making sense? Making sense? Yes or no? Everybody, please look here. Is this making sense to you? Yup. So when you say 5 plus 1 by 2th term is actually the middle term, how can you write this? How can you write this? Tell me. Or let me write in a general setup, right? Let me write in a general setup. When you have a plus b to the power n and your n is odd, number of terms in the expansion are even, you get 2 middle terms. What are the middle terms? T n plus 1 by 2th term and T n plus 1 by 2 plus 1 just after that. So how do you express this? See, n plus 1 by 2 is what? N minus 1 by 2 plus 1. You always write something plus 1. This will give you nc n minus 1 by 2, a to the power n minus 1 by 2, b to the power n plus 1 by 2. The next middle term is T n plus 1 by 2, T n plus 1 by 2 plus 1. This will look like nc n plus 1 by 2, a to the power n plus 1 by 2, b to the power n minus 1 by 2. Yes, ma'am, no, ma'am. And here there is a magic. Both these middle terms are not equal. I'm not saying both these middle terms are same. But look at their binomial coefficient. This is the binomial coefficient of one middle term. This is the binomial coefficient of another middle term. It's nothing but NCR and NCN minus R. They both are equal. They both are equal. Yes, people, when you have even number of terms in the expansion, you get 2 middle terms. Yes, there are 2 middle terms. They can have different values altogether, but their binomial coefficients will match. Their binomial coefficients will match. Making sense? Their binomial coefficients will match. Guys, this page, this screen is super important. If you want me to go away from here, I'm going to go away from here. You can quickly take a screenshot. Quickly take a screenshot of all of this. It's very important. Please mind it. Mind it, folks. When you say, let me write it here. Before I reveal this beautiful, beautiful design to you, let me write it here. Okay. When n is even, middle term is what? N by 2 plus 1th term. And this has binomial coefficient as what? NC n by 2. When n is odd, you have 2 middle terms. They are n plus 1 by 2th term and n plus 1 by 2 plus 1th, just after that. And what are the 2 binomial coefficients when you write both these terms? It's nc n plus 1 by 2 as well as nc n minus 1 by 2. These are the 2 different looking binomial coefficients which come into play, but they both are actually equal. They both are actually equal. Actually equal. Got it? Is the story clear? So when n is even, you have odd number of terms in the expansion, you get exactly one middle term which has binomial coefficient as nc n by 2. When you have n as odd, there are even number of terms in the expansion, you get 2 middle terms. They both can be different in value, but their binomial coefficients might look different, but actually they are nothing but NCR and NCN minus R, and hence they are the same. Okay. Okay, now let me prove to you something very beautiful. I'm going to go away from screen. So for some time, you will just hear my voice. you will not be able to see me because I want you to see what I'm going to show you now. Look here. Look at the diagram, everybody. Look at the diagram. Look what's going on. It's going to amaze you. I am plotting just the binomial coefficients of a plus b to the power 2. So when you open a plus b to the power 2, you get 3 terms. First term has binomial coefficient 2c0. Second term has binomial coefficient 2c1. Third term has binomial coefficient 2c2. When you plot these binomial coefficients actually on the graph, you realize 2c1 is the highest in value. And 2c1 is the binomial coefficient of the middle term in this expansion. Yes or no? 2c0 a to the power 2 b to the power 0 plus 2c1 a to the power 1 b to the power 1 plus 2c2 b to the power 2. So this is the middle term. Middle term has binomial coefficient 2c1, which is actually highest in value. Now plot the binomial coefficients of a plus b to the power 3. This will have 4 terms, t1, t2, t3 and t4. 2 middle terms, t2 and t3. Both of them will have the same binomial coefficient. I told you that is why 3c1 and 3c2 are actually identically valued. But if you compare with 3c0 and 3c3, they are on top. Again, next, a plus b to the power 4. 5 terms in the expansion. Plot each of the binomial coefficients. You will realize there is a mountain setup being formed and the binomial coefficient of the middle term is the highest in value. It's the largest in value. Next, similarly, a plus b to the power 5. 6 terms in the expansion. 2 middle terms. Both of their binomial coefficients will be identical and they will be highest. This is a proof, bachche. This is a proof that binomial coefficient is maximum of the middle term. Is this making sense? The binomial coefficient of the middle term in the expansion is maximum, it's the greatest, it's the largest. Because when you plot the binomial coefficients, it forms a mountain setup. It forms the mountain setup where the peak comes at the binomial coefficient of the middle term. Always remember, whenever you plot the binomial coefficients of any expansion, it forms a mountain setup. The peak always comes at the binomial coefficient of the middle term. That's why it's the highest. So what you have to remember, NCR is maximum when R is n by 2, provided n is even, because in that case NC n by 2 is the look of the binomial coefficient, which has the largest value, and it is n minus 1 by 2 or n plus 1 by 2 when n is odd. In that case, it looks like NC n plus 1 by 2, which is same as NC n minus 1 by 2. Yup. Now that you absorbed this, we are through with one concept, which is highest binomial coefficient. Okay, let's come to this question. Sum of the real values of x for which middle term in this expansion is equal to 5670. Tell me how exactly are you going to crack this question? It's very simple. Look here, index is 8. Index is 8, which is even. This implies 9 terms in the expansion. 9 terms in the expansion. This means exactly one middle term. This means exactly one middle term. And what is that? It's NC n by 2, a to the power n by 2, b to the power n by 2. The sum of the real values of x for which the middle term in this binomial expansion is this. So middle term will be NC n by 2 x cube by 3 to the power n by 2, 3 by x to the power n by 2. This is equal to 5670. Tell me if this is making sense. So 8c4 x to the power 12 upon 3 to the power 4 into 3 to the power 4 upon x to the power 4. This gets cancelled out. Tell me, 8C4 x to the power 8 is 5670. Yup. Clear till here? What is 8C4? 8 into 7 into 6 into 5 upon 4 factorial 24, 6 into 4, 4 into 2, 14 into 5 is 70. This is 70. 70. So x to the power 8 is 5670 upon 70. So this gives you 81. 81 is 3 to the power 4. So you get x square to the power 4 is 3 to the power 4. That means x square comes out to be plus minus 3. But x square can never be equal to minus 3. So x is equal to plus minus root 3. That means the sum will come out to be a big fat 0. The sum is a big fat 0. Yes? No? Come on, quick. It's 0. Easy. Once you've understood middle term, once you know the look of the middle term, when n is even, when n is odd, everything becomes a cakewalk. I hope this question is hashtag HDCC, everybody. Is this high definition crystal clear? Is the connection strongly built? Everything being hashtag Bhoomified? Yup. Come to this one. Fantastic sawal. Fantastic. Look at this. Classic JEE Main question. Classic. Let the coefficients, just the coefficient. In the previous question, we were talking about the complete term. Here, we are only talking about coefficient. Let the coefficient in this expansion, respectively, form the first 3 terms of an AP. Chalo, cool. Coefficient of the middle term. Chalo, look here now. 4 is even. Carefully. 4 is even. Number of terms in this expansion will be 5. That is odd. It will have exactly one middle term, which will look like n c n by 2. A to the power n by 2, b to the power n by 2. So 1 by root 6 to the power 2 and beta x to the power 2. Theek? What is this simplify? This is 4c2. 1 upon 6 to the power 1 by 2 into 2. So this is just 1 by 6 beta square x square. 4c2 is also 6. So 6 cancels out. You are left with beta square x square. Yes? But the question says you need just the coefficient of the middle term. This is your complete middle term. So coefficient of the middle term means you just need beta square, bache. You just need beta square. Moving on to the next one. What is this? This is the expansion. Here again, index is even. Number of terms in the expansion will be odd, which is 3. If 3 terms in the expansion, only one middle term. What will it look like? n c n by 2. A to the power n by 2 minus 3 beta x to the power n by 2. Is this cool? Look here. Is this cool? Is this cool? What next? This is 2c1 minus 1 and then 3 beta x. 2c1 is just 2. 2 into 3 is 6. So minus 6 beta into x. That means minus 6 beta is actually the coefficient. Yes? Up next is this expansion. 6 is the index. Again, this is even. 7 terms in the expansion. Only one middle term. What will it look like? This is 6c6 by 2, ncn by 2. 1 to the power n by 2 minus beta by 2x to the power n by 2. So 6c3, you will have minus 1 to the power 3, which is minus 1 only, all right. Beta to the power 3 upon 2 cube is 8x cube. Tell me. Tell me, is this clear? What is 6c3? 6 into 5 into 4 upon 6, this gives you 20. So you will get minus 20 beta cube by 8x cube. Cancel this out. This is 4, this is 10, this is 5, this is 2. So minus 5 beta cube by 2x cube. That means this is your coefficient. These are your 3 coefficients which are forming first 3 terms of an AP. Guys, this question is calculation heavy, but this is supremely important. It's going to clear so many concepts of yours. I can't even begin. All right. So you have beta square, carefully write. beta square minus 6 beta, and then you have minus 5 by 2 beta cube. This is forming an AP. So what does this mean? Twice the middle term is sum of the first and the third. Yes, beta gets cancelled out, beta is positive. So minus 12 is equal to beta minus 5 by 2 beta square. That means you get minus 24 is equals to 2 beta minus 5 beta square. That means you eventually get 5 beta square minus 2 beta minus 24 is 0. This is a quadratic equation in beta, people. Are you realizing this? Quadratic in beta. It's quadratic in beta. You can break the middle term. 5b square minus 12 beta plus 10 beta minus 24 is 0. Yes? Yes, ma'am, no, ma'am. All right, plus 10 beta minus 12 beta. Okay, so 5 beta comes out common, beta plus 2 minus 12 comes out common, beta plus 2. That means beta is coming out to be minus 2 or 12 by 5. Because beta is given to be positive, you can't take it to be minus 2. That means acceptable value of beta is 12 by 5. The question is done. The question is almost done. Because you have to compute 50 minus 2d by beta square. So 50 minus 2 by beta square. What is the value of d? D is the common difference, which is minus 6 beta, second term minus first term, minus beta square. Minus 6 beta minus beta square. Minus 6 beta minus beta square. So 50 plus 2 into 6 beta plus beta square upon beta square. So 50 plus you get 12 by beta plus 2. So 52 plus 12 by beta. Beta is coming out to be 12 by 5. This gets cancelled out. 57 is your final answer. 57 is your final answer. Yes, ma'am, no, ma'am. Any confusion? Any doubt? Stop me right now, right here, and ask me. Any confusion, any doubt, everyone? Hello, good evening. Tell me. Any doubt, anyone? Stop me right now. Ask me right now. Cool, hai? Cool? I've already told you independent. But here, let me raise the bar a little bit. Everybody, let me raise the bar a little bit. If the maximum value of the term independent of t in this expansion is k, what is 8k? The language is confusing. The language 100% for sure is confusing. What is it trying to say? Maximum value of the term independent of t in this expansion. First of all, write the general term. Let's first of all quickly write the general term. Please write the general term. Are you writing the general term? Quickly write the general term. This is 15 CR t square x to the power 1 by 5 to the power 15 minus r 1 minus x to the power 1 by 10 upon t whole to the power r. This is your r plus 1th term. Bhai Saab, this is pretty overwhelming. This is pretty overwhelming. Yes or no? This is pretty overwhelming, but it's okay. One step at a time. One step at a time. 15 CR. This is T2 into 15 minus R. Then there is T to the power minus R. All of this is involving T. X to the power 15 minus R upon 5. And there is X to the power, or rather 1 minus X to the power R by 10. Perfecto. So 15 CR, T to the power 30 minus 2R minus R. So minus 3R. X to the power, this is 3 minus R by 5. 1 minus X to the power R by 10. Perfect. This is your R plus 1th term. Okay. You want your term, this is your complete term. You want your term to be independent of T. For it to be independent of T, this power has to be 0. That means 30 minus 3R has to be 0 or R should be 10. When you take r as 10, your term will come out to be independent of t. When you take r as 10 means your 11th term. What will you get? 15c10 t to the power 0, obviously, x to the power 3 minus 2, that means x to the power 1, and 1 minus x to the power r by 10, 10 by 10 is 1. So what you end up getting is 15c5, because NCR is same as NCN minus r, x into 1 minus x. Yes, ma'am. No, ma'am. Yes. Now, what is it saying? Term independent of t, though you have computed. It is demanding from you its maximum value. Term independent of t, so chalo, it has computed. Fine. We wrote the general term. We equated power of t to be 0. And that is how we got the term independent of t. But now I have to maximize it. So this is acting like a function of x, bache. And the aim is to maximize f. How do you? Yes! I was about to ask the question and I got the answer in the comments. High five, Samrat. High five. How do you maximize? You compute the derivative. 15c5 as it is. X into 1 minus x first term, differentiation of second, plus second differentiation of first. 15c5 minus x plus 1 minus x. So 1 minus 2x. Equate it with 0. Your x will obviously come out to be half. Is this cool? Any doubt? Anyone? Tell me right now. Tell me right now. Any doubt? Anyone? X is half. You can use the first derivative test or the second derivative test. If you compute second derivative, what will you get? 15c5 minus 2, which is negative, for x equal to half. So this is your point of maxima. So corresponding to x equals half, you're getting the maximum value. So what will be the maximum value? Here, maximum value will be 15c, it was 15, 15c5. T to the power 0, x is half and 1 minus half is again half. So 15c5 by 4, this is the maximum value, which is given to you as k. Once you have your k, you can very easily compute 8k. You can very easily compute 8k. Is this cool? Isn't it a nice question? You have k with you, you can compute 8k. See, 15c5 upon 4 is your k. So when you say 8k, that means 8 by 4. 15c5 means 15 into 14 into 13 into 12 into 11 upon 5 factorial, which is 120. This is 2, this is 60. Very simply, you will get 6006 as your answer. Just basic arithmetic. Yes, it's a multi-conceptual question. It's very, very nice. And questions like these are asked in your paper. They have been asked. They are being asked. They will be being asked. They are going to be asked 100%. Hi, Sai. Yes, 6006 is the final answer. Right answer, correct answer. Hashtag HDCC, everybody. Yes, ma'am. No, ma'am. This is again a fantastic question, which is going to literally blow your mind away. This is how multi-conceptuality happens in math, which raises the difficulty level of math. But once you acquaint yourself with all varieties of questions, that's when your confidence increases. That's when you go and take the paper, no question actually surprises you. Okay, and that is what is my agenda. No question in the paper should be a surprise for you. No question in the paper should be unfamiliar to you. With every question, you should sense a familiarity and you should feel the confidence and the happiness to go and attack it and conquer it as well. Kill it, smash it, crush it. Let's go. Alpha positive, beta positive. This relationship is given to you to be holding true. If maximum value of the term independent of x in this expansion is 10k, what is k equal to? Maximum value of the term independent of x in this expansion, general term will look like what? 10cr alpha x to the power 1 by 9 to the power 10 minus r, beta x to the power minus 1 by 6 to the power r. Okay? Write the constant term, you get alpha to the power 10 minus r, beta to the power r, x to the power 10 minus r by 9 and x to the power minus r by 6. Okay, so minus r by 6. You want the term independent of x. This is your complete constant part, this is variable part. You want the term to be independent of x, that means this is what you want to be equal to 0. Yes, no? This is what you want to be equal to 0. So you get 10 minus r by 9 is equal to r by 6. So 20 minus 2r equal to 3r, 20 is equal to 5r, or r is equal to 4. That means your fifth term is independent of x. Fifth term is 10c5 alpha to the power 10 minus r. This is r. So alpha to the power 10 minus 5, which is 5, beta to the power 5. This is the term independent of x. In fact, you can realize this is the middle term. Yes or no? Middle term? Okay, we don't have x involved. So let's just talk about the term independent of x right now. This is the term independent of x. This is the term independent of x. It says if the maximum value of this term is 10k. How to compute the maximum value of this term? You have 10c5 alpha to the power 5 beta to the power 5. When you say you have to compute the maximum value, what do you mean? Acha, r is 4, na? Oh, r is 4. R is 4. So here you will get 10c4 alpha to the power 6 beta to the power 4. Correct. My bad. R is 4. Yes, you are so correct, Samrat. AMGM inequality screaming to be used loudly at the top of its voice. You have 10c4 bache, alpha to the power 6, beta to the power 4. When you say you want its maximum value, that means you want this expression to be less than equal to something. This something will represent its maximum value. Making sense? Making sense? How will you get to the maximum value? And the answer is AMGM inequality. Look here, if alpha is positive, beta is positive, obviously alpha cube is positive and beta square is also positive. AMGM inequality is applicable only on non-negative entities. How many of you all know this? AMGM inequality is applicable only on the non-negative entities. And here alpha, beta, alpha cube, beta square, everything is non-negative. In fact, they are positive. They are positive. So what will I do? I'll play smart. This is something I have taught you tremendous number of times in quadratic, while in sequence series when we are doing AMGM. Every time I have taught you this, I don't know, with plethora of examples. Alpha cube by 2, alpha cube by 2, beta square by 2, beta square by 2. On these four positive terms, you apply your AMGM. Yes. Why, ma'am? You'll just understand in a jiffy. You literally understand in a jiffy. There's sum. Alpha cube by 2 plus alpha cube by 2 means 2 alpha cube by 2. You will get alpha cube. Then you will get beta square whole upon 4 because these are 4 terms. Arithmetic mean is greater than or equal to the geometric mean, fourth root of their product. Alpha cube by 2 into alpha cube by 2. Then beta ki power 4 by 4. Arithmetic mean greater than or equal to geometric mean. Clear? Alpha cube plus beta square is already given in the question to be 4. So my left hand side is completely 1. You are getting alpha to the power 6, beta to the power 4 upon 16. Its fourth root is less than or equal to 1. This is what? 2 to the power 4. 4 into 1 by 4 is 1. So you are getting alpha to the power 6, beta to the power 4 to the power 1 by 4 is less than or equal to 2. Or you can say alpha to the power 6, beta to the power 4 is less than or equal to 16. 2 to the power 4 basically. You raise both sides by power 4. That means this is the maximum value. This is the maximum value. Oh, I think green color is not being visible to you properly, is it? I should not be using green. I'm so sorry. I realized it right now. Green color, I guess, is not visible to you very nicely. Okay. Moving ahead, I'll make sure of this. All right. Clear, people? Clear till here? Clear till here? Yes? What you needed was 10C4 into this expression's maximum value. It's coming out to be what? 10C4 is the constant into 16. This is the maximum value which is given to you as 10K. Of course, open up 10C4, cancel out the 10s, you will be left with K. K is your answer. K is your answer. Is it cool? Everyone, give me a good to go. Give me a quick good to go. Give me a quick hashtag HDCC. Is this clear? Because we are through with our concept of middle term, independent of x, rational, integral. All these things are done. We are now going to dive into the next concept, which is numerically greatest term. Now, I told you, everybody, eyes, ears, pop open. Eyes, ears should pop open. Listen to me carefully. Listen to me carefully. I told you, highest binomial coefficient is that of the middle term. What about highest coefficient? What about highest term? For that, now I'm going to tell you something. See, look at the expansion a plus b raised to the power n, nc0, a to the power n, b to the power 0, and so on. In each of these terms, there is a binomial coefficient. I know that your binomial coefficients are natural numbers. Oh, natural numbers, they're always positive. That is why we say largest binomial coefficient or greatest binomial coefficient or highest binomial coefficient. But understand, if I plug in specific value of A and B, if I plug in specific value of A and B, each of these terms will come out to be a real number. Each of these terms will come out to be a real number. I don't know, positive, negative, whatever. NCR is always positive. But if I plug in specific value of A and B, each of these terms on getting simplified will come out to be some real number, positive, negative. So I will not say greatest term. Rather, I will say numerically greatest term because I am interested in the absolute values of these terms. When you say minus 36 and 20, of course 20 is larger algebraically, but numerically, this is larger. Getting my point? What did I say? If you compare minus 36 and 20, 20 is larger, but algebraically, numerically, that means absolute value wise, minus 36 is larger because its mod is greater than 20's mod. Minus 36 is farther away from 0 than 20 is. The distance is more. So whenever we talk about greatest term in an expansion, we say numerically greatest. We don't just say greatest because a term can come out to be positive or negative. Got that? Got that? So binomial coefficient, simple. Highest binomial coefficient, greatest binomial coefficient, largest binomial coefficient is that of the middle term. But term and coefficient, you know the difference now between binomial coefficient and coefficient? So term and coefficient, we don't compute them to be highest or largest or greatest. We say numerically greatest, numerically highest, numerically largest. Okay? Oh, that's so sweet. Working hard. I so appreciate that, bache. I so appreciate that. Chalo, now how to compute numerically greatest term? It's very, very important for you to understand this point because there are hundreds of students, thousands of students who are confused in this topic. Now listen to me carefully. When you say a plus b to the power n, it has term 1, term 2, term 3, term 4, and so on, term n plus 1. Listen to me carefully now. When you were plotting binomial coefficients, what did you saw? What did you see? That it was being drawn in a mountain setup. And the peak was coming at the binomial coefficient of the middle term and hence it was representing the highest. Kind of same thing happens when you plot the terms. You have assigned specific values to A and B. Now every term is a real number. You take their absolute values and you plot them. When you plot them, it again somehow comes out to be in a mountain setup. This time I am not saying the peak will be occupied by the middle term. No. Any term can occupy the peak position. Any term. Let's say fourth term. So before it, there are 3 terms. After it, there are 5, 6, 7, 8, 9, how many ever terms? N plus 1th term. I don't care. But the peak is occupied by the numerically largest term. The peak is occupied by the numerically largest term. Is this making sense? Is this making sense? When you, listen to me again, when you plug in specific values of A and B, every term comes out to be a real number. You compute their mod, compute their absolute values, compute their numerical values, plot them. The term which has highest numeric value will be occupying the peak position of this mountain. And that is why when you have to prove that a term is numerically largest, all you need to prove is that that term is numerically largest as compared to its immediate previous term and as compared to its immediate next term. If it's numerically largest with respect to its previous term, it will obviously be greater than the remaining previous terms. If it's greater than the immediate next term, it will obviously be greater than the remaining next terms because of the pahar setup, the mountain setup. So if I have to claim that my term 4 is numerically largest, all I need to prove is that it is greater than the third term and greater than the fifth term. Greater than or equal to. It can also happen that you have something like this. Something like this. So there is a flat line, something like this. Like remember, it happened in the case of binomial coefficient as well, that your term 4 and term 3 both are equal. This is term 5, term 6 and so on. This is term 2 and term 1. So it can happen that your numerically largest term, which is term 4, is actually equal to the third term also. That can also happen, not a problem. So what I need to prove is, I have to prove that your term 4 is greater than or equal to the term 3 and your term 4 is greater than or equal to term 5 numerically. How many of you all have understood this? How many of you all have understood this? If your term 4 is numerically greater than its immediate previous and immediate next term, then it will be greater than the remaining terms of the expansion because of the mountain setup. Yes? Understood, visualized? And hence, whenever you have a plus b to the power n, here you say your r plus 1th term is numerically greatest if and only if your r plus 1th term is greater than or equal to the rth term numerically and your r plus 1th term is greater than or equal to r plus 2th term numerically. That means r plus 1th term is greater than its immediate preceding term and r plus 1th term is greater than the immediate succeeding term. Yep. Now look here. What does this give you? When you say tr plus 1, mod of tr plus 1, you get ncr a to the power n minus r b to the power r. Its mod greater than or equal to ncr minus 1 a to the power n minus r plus 1 b to the power r minus 1. I'm talking about the first condition. This is second condition. And will give you, intersection will give you the final condition. Okay. Now see, ncr upon ncr minus 1. All right. Greater than or equal to a to the power n minus r plus 1 b to the power r minus 1 upon a to the power n minus r b to the power r. Now ncr minus 1, everything is positive. All right. Can I use my result here? Can I use my result here? I have a big smile on my face. Can I use my result here, everybody? Can I use my result here? This will be what? N minus r plus 1 upon r. This is greater than or equal to what? A to the power, yes, n minus r plus 1 minus n plus r. So this goes, this also goes, you're left with a. and this is similarly BR minus R plus 1, so B. Got it? Yes, ma'am, no, ma'am. So you are left with n plus 1 by R minus 1 greater than equal to mod of A by B. Or you can say you will get n plus 1 upon R greater than equal to 1 plus mod of A by B. See this? Getting my point? It's a very, very, very important concept. Bache, look here. R will be hence less than equal to n plus 1 upon 1 plus mod A by B. This quantity is your M. So from the first condition, you get R is less than equal to M. And from the second condition, you get R is greater than equal to M minus 1. That's for sure. That's for sure. When you solve the second condition in the similar manner, again your shortcut will be used. From here to here, your shortcut is used, right? Which is your direct result. Again, it will be used. You will end up getting R is greater than equal to M minus 1. So what are you getting? You are getting that your TR plus 1 is numerically greatest term if and only if your R is greater than equal to M minus 1 and less than equal to M, where M is what? What is M? N plus 1 upon 1 plus mod A by B. Right? What is A by B? Expansion is A plus B to the power N. So quantity written before plus is A, quantity written after plus is B. This is numerically greatest term in A plus B to the power N if and only if. This is very, very important. But here's a word of caution, people. Here's a disclaimer. Two cases arise. First, when M is an integer. What happens when M is an integer? Say M, for example, M is 3. Okay? Then your R is sandwiched between 3 minus 1 and 3. So you have two acceptable values of R, 2 and 3. So your third term and fourth term happen to be the numerically greatest terms. That means third term and fourth term means what? Means what? Means what? Mth term and M plus 1th term. If M is 3, third and fourth term are numerically greatest. That means when M is an integer, mth term and M plus 1th term happen to be your numerically greatest terms. On the other hand, if M is not an integer, what happens? Suppose M is, for example, 3.2. Then R is greater than equal to 2.2, less than equal to 3.2. Yes? So R is what? R is a whole number. It cannot be a decimal. It cannot be a decimal. So only acceptable value is 3. Between 2.2 and 3.2, only acceptable value is 3. That means TR plus 1. T4 is your numerically greatest term. Now, when you say T4, what do you mean? How can you generalize? When M is not an integer, you consider GIF of M, which is in this case 3. So T4 is coming out to be numerically greatest. That means what you end up saying is T GIF of M plus 1 is numerically greatest. Guys, please take a look at this. It's very important. My Telegram ID, everybody, it's study with Bhoomika Ma'am. Okay, that's a TG ID. Guys, note it down. But here, make sure you understood both the cases. Your M can be an integer. Your M might not be an integer. These are the only two cases. When M is an integer, mth term and M plus 1th term happen to be your two numerically greatest terms. In this case, you get two numerically greatest terms. Two numerically greatest terms. Got it? And in case when M is not an integer, you get what? GIF of M plus 1th term happens to be your only one numerically greatest term. Only one numerically greatest term. Here you get two numerically greatest terms, and here you get exactly one numerically greatest term. Is this making sense, everyone? Is this making sense? Very, very important. Whatever I have explained in these last two slides, the concept of pahad, the mountain, how have we reached to this condition? How have we then concluded what actually the terms are going to be numerically greatest? Very important, people. Take a screenshot. Ask me to move away from the screen. I'm going to move. Please take a screenshot, guys. Please take a screenshot. Taken this page, further this page. Okay, and last is this page. Very, very important. Got it? Chale? Moving ahead? Moving ahead? Let's go. Let's go, let's go, let's go, people. This is done. I have proved all this to you. I hope it's clear. All right, come here now. Very, very simple. How actually do you apply this? Greatest term numerically in this expansion when x is 3 by 2. Now see, you have 2 plus 3x to the power 9. 2 is acting like your A, 3x is acting like your B. What do? You compute m, which was n plus 1 upon 1 plus mod A by B. So n is what? 9 plus 1 upon 1 plus mod A by B, 2 upon 3x, corresponding to x equal to 3 by 2. Because until and unless you don't plug in the value of the variable, you cannot compute the numerically greatest term. You will have to plug in the value of x. You will have to plug in the value of x. So you are getting what? 10 upon 1 plus 2 by 3 into 3 by 2. Tick. This gives you 10 upon 1 plus 4 by 9, which gives you what? 90 upon 13, which actually comes out to be 6 point something. Oh, 6 point whatever. This is not an integer. So your m is not coming out to be an integer. This means T, GIF of m plus 1 is your numerically greatest term. What is GIF of m? 6. 6 plus 1, 7, which implies 7th term is your numerically greatest term. What say, people? Absorbing? 7th term. Remember the result when m is not an integer? GIF of m plus 1th term is your numerically greatest term. That's how small the question is. That's how small the question is, but only when you understand. Only when you understand the entire derivation, entire concept, that's when you are able to reach to the answer so fast. 7th term will be numerically greatest term. You can very easily compute the 7th term. A is the right answer. This is your homework question. Exactly same. Exactly same. Come here now. Oh my God, this question will blow your mind. We'll take a break at 8 o'clock. Don't worry, people. We'll take a break at 8 o'clock of 30 minutes. And then I'll be back. We'll be finishing this portion. Then we'll be just left with binomial series and multinomial. That's it. This portion is about to get completed. You are through with the actual part from where the questions are asked and which are scoring questions. After this, we have multinomial, again a very scoring topic, and some binomial series which you must remember by heart. I will make them super easy for you. And before that, I will give you a break. So we'll rejuvenate ourselves. I'll give you a break of 30 minutes and then come back. Come to this question. Is the greatest term in this expansion? This is a fantastic question, people. Oh my God, mind-blowing. Mind-blowing. It's a superstar. Look at the statement. Please look at the statement. Look at the statement. It says, greatest term in the expansion has the greatest coefficient if and only if x belongs here. And the 4th term in this expansion is n by 4. What is the value of m lambda? Guys, the question's statement is the only thing which is complicated. Once you decode the statement, the question is a child's play. It's like as easy as walk in the park. It says greatest coefficient belongs to the greatest term. Okay? Now 1 plus x to the power 2n. Look here. 1 plus x, please look here. How will you write its general term? It's 2ncr 1 to the power 2n minus r, x to the power r. What does this mean? Carefully observe. What does this mean? Here is the binomial coefficient. Which is the coefficient? Generally, it doesn't happen. Generally, your binomial coefficient is one part. involve it with more constants, that becomes the coefficient. Bring in the variable in picture, that becomes the term. Right now, only the binomial coefficient represents the constant part. There are no other constants. So the binomial coefficient is the coefficient. And it says greatest coefficient. That means the question is talking about greatest binomial coefficient. So here there is a hidden word binomial, which actually is what is making all the difference. This is what is making all the difference. It's hidden. You have to decode it. Because here coefficient only is binomial coefficient. And you know the binomial coefficient is greatest of the middle term. Right now your index is even. Index is even. So your middle term will look like what? Your middle term will have the greatest binomial coefficient. It will look like 2nc, 2n by 2, 1 to the power 2n by 2, x to the power 2n by 2. Yes or no? nc n by 2, a to the power n by 2, b to the power n by 2. Remember? This is 2ncn x to the power n. This is your middle term. This has the highest binomial coefficient, or rather, in term of the question language, this is the highest coefficient, which belongs to the greatest term. That means this is the greatest term. Oh my God. Oh my God. Everything has coincided in this question. The highest binomial coefficient and the highest coefficient have coincided, but that belongs to the middle term, and middle term, that means, has to be declared as the greatest term. Everything has been coincided. Now, if this is the greatest term, that means this is the only greatest term, and that means you have only one greatest term. In which case you have only one greatest term? When your m is not an integer. This is the only greatest term. That means this is nothing but GIF of m plus 1th term. Yes or no? This is GIF of m plus 1th term only, na? Yes or no? Tell me. But actually this is which term? This is n plus 1th term. Actually this is n plus 1th term. Actually, technically, this is n plus 1th term. But if this is the greatest term and this is the only greatest term, that's only possible when the term looks like GIF of m plus 1th term. That means n plus 1 is nothing but GIF of m plus 1, or I can say n is nothing but GIF of m. Yes or no? N is nothing but GIF of m. M is what? M is what? Tell me. Tell me. When you say this is GIF of m plus 1th term, when does this happen? When do you get GIF of m plus 1th term as your middle term? When m is not an integer. When m is not an integer. So this means m here is not an integer. What is m? What is m? 1 plus index. 1 plus index upon 1 plus, this is what? 1 by x. This is not an integer. And here, to simplify things, I will give you a suggestion. Instead of treating this as a and this as b, 1 plus x is same as x plus 1. So you treat this as b and this as a. This is the only thing I would suggest you to do. Even if you don't do, you'll get the same answer. Just do it so that here you get an x. And x belongs here, that means x is positive, so no need of the mod. Okay? M is not an integer, right? But you know GIF of m is equal to n. GIF of m is equal to n. When is the GIF of any quantity equal to n? When that quantity is lying between n and n plus 1. When that quantity is lying between n and n plus 1. So this means 1 plus 2n, and GIF of 1 plus 2n upon 1 plus x is equal to n. That means this quantity is lying between n and n plus 1. Remember functions, this much you remember, right? When a quantity lies between two consecutive integers, its GIF is the one sitting to the left of it. You can write equality also, but here they won't be equal, so you can very surely write just the strict inequality. Making sense? Okay? When you simplify this, this is when you get Simplify this part, you will get x is greater than n upon n plus 1 and less than n plus 1 upon n. It's very simple. Very easy to simplify. You will get x is greater than n upon n plus 1 and less than n plus 1 upon n. But it's given in the question that x is greater than 10 upon 11, less than 11 upon 10. Compare. Guys, compare. What is n? Just compare. N is nothing but 10. N is nothing but 10. Yes or no? N is nothing but 10. How many of y'all have understood? Are you getting 10? Yes, Samrat. N is nothing but 10. The moment you have n as 10, what do you get? You get this is 10 and 10 by 4 is 5 by 2. It says fourth term in this expansion. Expansion is this one. Fourth term in this expansion. Fourth term is T3 plus 1. You will get MC3 lambda x to the power m minus 3 1 by x to the power 3. This is 5 by 2. See this? That means you are getting MC3 lambda to the power m minus 3 x to the power m minus 3 minus 3. So m minus 6. This is equal to 5 by 2. Now please make sure that you are able to observe left hand side has a constant part and a variable part. But right hand side has only the constant part. The variable part is x to the power 0. If these two are equal, that means m minus 6 has no choice but to be 0. So m minus 6 is 0 implies m is 6. M minus 6 is 0 means m is 6. The moment m is 6, now what is lambda? The moment m is 6, that means this gives you 6c3 lambda to the power 6 minus 3. This is equal to 5 by 2. And from here, when you solve, you get lambda equal to half. So m lambda 6 into 1 by 2, 3 is your answer. Very, very conceptual question. If you don't understand the concept of numerically greatest term, there is no chance for you to be able to crack this question. It's very conceptual. It's very, very, very insightful. It is highly deep diving into the idea, the very concept of greatest term. You can't just cram and get this question right. You can't ratify and get this question right. Many times I see teachers just making students cram, okay, this is the formula, step 1, step 2, get the numerically greatest term. But questions like these, you need the in-depth knowledge of numerically greatest term, without a doubt. Without a doubt. Once you have to understand, and then all questions will be in your pocket very smoothly, very frankly. This is another type of question which I feel you should do by yourself, but this time the question doesn't say greatest term, doesn't say greatest binomial coefficient, it says greatest coefficient. And it's very simple. Please understand. Index n of this binomial expansion, what is it if the ninth term of the expansion has numerically greatest coefficient? Now see, look here. I have the solution for you. See, ninth term. When you write the ninth term, what do you get? What do you get? This is 8 plus 1, right? So you get NC8 x by 5 to the power n minus 8, 2 by 5 to the power 8. This is the ninth term. The question says this term has the greatest coefficient. But you please understand one thing. When we were talking about greatest term, when were we in a position to talk about greatest term? Only when A and B were given fixed values. That means there was no variable involved. Every variable was assigned a certain value so that every term looks like a real number. Then we computed the absolute values and then we compared. So saying greatest term or saying greatest coefficient, isn't it the same? The only condition extra involved is when you say greatest coefficient, you are plugging x as 1. Or whatever the variable is, you are plugging it as 1 so that only you are left with the coefficient part. Otherwise, the story is actually the same. Greatest coefficient, greatest term, no difference. When you say greatest term, it's corresponding to any value of x, any value of y, any value of the variable. We just want the terms to come out to be real numbers. When you say greatest coefficient, The only condition attached is their x is equal to 1 or y is equal to 1, whatever variable is involved, that is 1. The story is exactly the same. Got it? And that is why here again I'm going to do the same thing. So what does it say? Coefficient is the largest. What is the coefficient? NC8. This is 2 by 5, right? So 2 by 5 to the power 8. 5 to the power 8 minus n, x to the power n minus 8. This is the coefficient. This is the coefficient. The variable part will vanish because you will plug in x as 1. Is this clear? Is this clear? This will further get simplified. This is 2 to the power 8, 5 to the power 8 minus n minus 8. So 5 to the power minus n. Getting my point? It says ninth term has numerically greatest coefficient, or I can say ninth term is the greatest term corresponding to x equals 1. Means the same thing. Ninth term is the greatest term corresponding to x equals 1, and this is the greatest term. This is the greatest term corresponding to x equals 1. So language, it's just language. Greatest coefficient, you say. Ninth term has the greatest coefficient, or ninth term is the greatest term corresponding to x equals 1. Means the same thing. So if this is the greatest term, this is the only greatest term, this is only possible. You get one greatest term only when your m is not an integer. So this implies your m is not an integer. And this greatest term is actually your GIF of m plus 1th term. But actually this is which term? Ninth term, that means 8 plus 1. So your GIF of m is nothing but 8. If your GIF of m is nothing but 8, that means your m is sandwiched between 8 and 9, right? That's what is written over here. And what is your m? What is your m? Tell me. What is your m? Tell me. 1 plus index upon 1 plus mod of a by b. X upon 5 divided by 2 by 5 multiplied by 5 by 2. This gets cancelled, this gets cancelled. You are left with 1 plus n upon 1 plus mod of x by 2. But x is 1, so 1 by 2. 1 plus 1 by 2 gives you 3 by 2. That's it. This is exactly what is written here, people. That your n plus 1 upon 3 by 2, this quantity is representing m is sandwiched between 8 and 9. When you simplify, your n comes out to be sandwiched between 11 and 12.5. The only one integral value which is acceptable is 12. Look here. Look here. M is sandwiched between 8 and 9. Simplify. What do you end up getting? What do you end up getting? N is sandwiched between 11 and 12.5. The only acceptable integral value of n is 12. You're done. You are done. So we are through with highest binomial coefficient, which belongs to the middle term. Highest coefficient, which is nothing but the highest term corresponding to x equals 1. And obviously the greatest term, but numerically. Okay? Alrighty. From application onwards, I'm going to start after 30 minutes. So let's take a quick break of 30 minutes. We will meet at 8:30. What are we going to do? Obviously, the application, which will involve the remainder problems. Very, very important. Highly repeated category of questions. Then binomial series. And obviously then multinomial theorem. Won't take much time. Cool? I am doing awesome. I hope you people are doing great too, because we are through with halfway binomial, halfway left, but this halfway is going to proceed very fast. We're going to proceed very fast with this half, because now that the basics are clear, now that all the important ideas have completely embedded in your system, we just have to use them, and we're going to crush these 3 subtopics like this. So I'm going to see you super soon again, guys. Please be back by 8:30. Don't forget, the session still remains to be completed. One shot of binomial will be done today, no matter what. All right? Take care and come back. Have something to munch, have something to drink, and come back. I'll see you. Hello, people. welcome again. I hope you all have munched something. You'll have had something to drink and eat, because now I'm all set to dive into the next part of binomial theorem, which is going to reveal some brilliant applications. We'll understand how questions based upon applications are asked in the paper. These are all PYQs. After this, we're going to talk about some brilliant results based upon binomial series. You must remember them. Just like the previous 5 results right in the beginning, I told you to remember. In the similar fashion, these binomial series I will teach you in such an easy way that everything will get absorbed very naturally. Okay? Am I live, people? Quickly give me a good to go. Are we live? Yes? Are we live? Awesome. After that, we're going to target multinomial theorem, and that's it. So let's go, everybody. Let's go to this question. What is the remainder when 2021 to the power 2022 plus 2022 to the power 2021 is divided by 7? A very famous PYQ based upon remainder, which will reveal a brilliant shortcut, which is by me called the go went gone method. So this is a proper shortcut reveal question. How exactly will you target it? There is no need for you to expand this completely, open it up using binomial expansion, then take out terms common. No need. Please don't do all that. Please don't do all that. What will you do? All you have to do is express your base. What does the shortcut say? Express the base as multiple of 7 plus minus 1. This is your target. Always, if you want to simplify life for yourself whenever computing remainder, the base you have to express as multiple of divisor plus minus 1. Now, how will it happen here? See, 2021, when you divide by 7, you will get the remainder 5 corresponding to some quotient. Similarly, 2022, when you divide by 7, you will get the remainder 6 corresponding to, say, some other quotient. All right. Now, one base is this, 2021. Another base is 2022. I am going to write 2021 as 7 times k plus remainder to the power 2022. And next base is 2022. I will write 7 times k dash plus 6 to the power 2021. Now comes into action the go went gone method. It says wherever you see 7 or multiple of 7, strike it off, go went gone. This is equivalent to 5 to the power 2022 plus 6 to the power 2021. That means whatever remainder you will get when you divide the original expression by 7 is the same remainder that you will get when you divide now this revised simplified expression by 7. So why not deal with simplified expressions, isn't it? Why not deal with this simple expression? And now again, the story is the same. This is the base 5, this is the base 6. Express it as multiple of 7 plus minus 1 as far as possible. So 6 I can very easily write as 7 minus 1 to the power 2021. From here again 7, go went gone, bye bye. 7, remember, go went gone, bye bye. You are left with minus 1 to the power 2021. That means minus 1. Okay, so one part is solved. What about this part? 5 to the power 2022. How can you express this in terms of 7? How can you express this in terms of 7? This calls for some mehnat. This calls for some hard work. You have 5 to the power 2022 plus here you had 6 to the power 2021. Remember, this part is very easily resolved. You wrote 6 as 7 minus 1 to the power 2021. 7, go went gone, bye bye. You are left with minus 1. So this part is completely resolved. What about this part? Any idea? Any idea? Anybody, any clue? Wild guess? Come on, quick. Anybody? How can I take 5 closer to 7 or any multiple of 7? We have 2022 as the power as well. What to do? 5 square? Nah, Naresh, no. You know what you have to do? You'll write 5 as 7 minus 2. This much so you can do. Now again 7. Go went gone, bye bye. So this becomes equivalent to minus 2 ki power 2022, which is same as 2 ki power 2022. Now you know I can write this as 2 cube and here 674. Yes or no? Because 2022 is a multiple of 3. It's divisible by 3 and 2 cube is nothing but 8. And 8 is nothing but 7 plus 1. And here 7 went gone. 1 to the power 674 is 1. Getting my point? Getting my point? So from one part, the remainder is coming out to be 1. The next part, remainder is coming out to be minus 1. Add, you get a 0. 0 is your answer. Or what you can do, actually, minus 1 is a remainder which we never accept. We always accept non-negative quantities. So actual remainder here is minus 1 plus the divisor, that is 6. So this is your remainder. This is your remainder. 1 plus 6 will give you 7. 7 because is the divisor. That means 7 divided by 7, remainder will come out to be 0 again. So your answer finally is 0. You can either get by adding 1 and minus 1. But minus 1 you don't accept as the remainder. Minus 1 plus the divisor. 6 is the remainder. So 6 plus 1 gives you 7. 7 divided by 7 again gives you 0 as the remainder. Okay? Is this clear? First question absolutely killed. Hashtag HDCC shortcut is completely clear. The only target is to express the base as multiple of the divisor plus minus 1. Got it? Moving on to the next question. Guys, tell me. Remainder left out when 8 to the power 2n minus 62 to the power 2n plus 1 is divided by 9. Anybody? Anybody? Any clue? Tell me quickly. Divided by 9. Now see, one very, very beautiful, I should say, arithmetic result. That's from number theory only. If something is divisible by m, it's divisible by any factor of m also. If m divides something, any factor of m also divides it. If m divides something, any factor of m also divides it. Yes or no? So here, carefully observe, you have 8 square to the power n minus 62 to the power 2n plus 1. This gives you 64 to the power n minus 62 to the power 2n plus 1. Carefully observe. 64 is 63 plus 1 and this is 63 minus 1. Now, this expression is divisible by 63. The remainder will come out to be 1. If I take divisor to not be 9 but 63, what if my divisor is not 9 but 63? 63 is multiple of 63. Go and gone. You are left with 1 to the power n, which is 1. So remainder is 1. Minus 63 again, go and gone. Minus 1 to the power 2n plus 1. Minus 1 to the power odd number is minus 1. So here you get minus 1. So you are getting 2. 2 is the remainder. Is this correct? Tell me, is this correct? Yes or no? Is this correct? Yes or no? Q? Why? Why? This is to divisible by 63, no? When you divide by 63, the remainder is 2. When you divide by 9, will the remainder still be 2? Yes? Yes, because 63 is nothing but 9 into 7. Here also 63 is nothing but 9 into 7. So you have done nothing. You have just expressed your base in terms of multiple of 9 plus minus 1. And that is why this was go went gone and you are left with 2 as your remainder. I was just confusing you, and if you got confused, lesson learned. ठीक है? Is this clear? Moving ahead. Look at this one. This was a very old AIEEE question. The last 2 digits of this number. Now, whenever the question asks you, very famous question, whenever the question asks you what are the last 2 digits of this number, it's equivalent to saying what is the remainder when 3 to the power 400 is divided by 10. This is a very important lesson learned, people. whenever the question asks you what are the last two digits of a number, you always equivalently answer what is the remainder when this number is divided by 10. Okay, that means now my agenda is to express the base in terms of multiple of 10 plus minus 1. Same logic, same shortcut. Multiple of 10 plus minus 1. Yes? Will you teach logarithm and inequality? Logarithm and inequality is something which is taught in the bridge course, Ashwin. Now we are 2 ahead in the game. If anywhere concepts get used of inequalities and modulus or whatever and logarithm, anything, any operator which I teach in bridge course, I will revise for you for sure. But full-fledgedly right now, because you have to focus on the JEE Main exam popping up very, very soon, maybe dedicated session, no, but whenever, wherever it comes in between the lectures, I will explain for sure. Okay? Okay? All right. 3 to the power 400. I can write this as 3 to the power 4 whole to the power 100. This gives me 81 to the power 100, which gives me 80 plus 1 to the power 100. Now, carefully observe. 80 is a multiple of 10. I have expressed my base very successfully as multiple of 10 plus 1. Now what? Now you expand this. Look here very carefully. This is 100C0, 80 to the power 100 plus 100C1, 80 to the power 99 and 1 to the power 1 plus 100C2, 80 to the power 98 plus and so on 100C98, 80 square, 100C99, 80 plus 100C100. ठीक है? All right. Now observe, please observe. From here till here, 80 square is present in every term. 80 square is 6400. So this term is having 6400. That means 2 zeros in the end for sure. The term before it will be 80 cube. 100% last two terms will be 0 because it has 80 square involvement. And so on. In each of these terms, I can for sure say last two terms will be 0. Yes or no? Last two terms will be 0. What about this? This is 100 into 80. That means this is 8000. And what is this? This is 1. So what are you getting? You are getting last two terms 0 of the sum from here to here. Next is 8000 and next is 1. That's it. Add all of this. What are the last two digits? 0, 1. And that's your final answer. And that's your final answer. Did you understand? The logic is the same. Compute last two digits of a number means what? Find the remainder when it's divisible, when it's divided by 10, when the divisor is 10. So you just have to express your base in terms of multiple of 10 plus minus 1. I did that. But now I need last two digits, right? Last two digits. What will I get? What will I get? The remainder you can see is 1 from here very easily. See, multiple of 10 means this is go went gone. 1 to the power 100 will give you 1. 1 is the remainder. From there also you could have ticked option D. But if you want to see it, then expand it. 80 square is 6400, which will be present in all the terms before it as well. So from beginning till 80 square, whatever the sum is, the last two digits will definitely be 0, 0. After that, next one is 8000, next one is 1. When you add all of it, what you end up getting is 0, 1 as the last two digits. Very, very important. Alrighty, these are all applications. Last three digits of the numerator of the number 7 to the power 100 minus 3 to the power 100. Tell me what do you think you will do? Last two digits I explained, last three digits you do. Here the hint is take the divisor to be 100. There you do the divisor to be 10. Here you take it to be 100. Okay? That's your homework. Answer is 0, 0, 0. Chalo. Next up is this. 11 to the power 27 plus 21 to the power 27 when divided by 16. What to do? What to do? One way is 16 minus 5 to the power 27 and 16 plus 5 to the power 27. So 16 go and gone, 16 go and gone. You get minus 5 to the power 27 plus 5 to the power 27. No. Who will do this much hard work? Again, I have to somehow convert my base in terms of 16 or multiple of 16 plus minus 1. But who will think all of that? It's so tricky, it's so tough, it's so complicated. This method is eradicated. Rather, it's time for a shortcut, people. See, x to the power n plus y to the power n is divisible by x plus y if and only if n is odd. How many of you all know this? How many of you all know this? Huh? Here, how will the shortcut get applied? 11 to the power 27 plus 21 to the power 27 will be divisible by 11 plus 21, which is 32, since 27 is n, which is odd. And if something is divisible by 32, it will obviously be divisible by any factor of 32, which is 16. And if it is completely divisible, that means the remainder is 0. So 11 to the power 27 plus 21 to the power 27 will be divisible by 32, and hence will be divisible by any factor of 32, which is 16 also. 16 is one of the factors. So it will be divisible by 16 completely, and hence the remainder will be 0. Shoot. Done. Dusted. Killed. Completely conquered. Come to this question now, very quickly. If the remainder when x is divided by 4 is 3, what is the remainder when this is divided by 8? Bhai Saab, this is a really important question. This is a really important question. When x is divided by 4, the remainder is 3. I don't know what the quotient is, remainder is 3. This means x is nothing but 4 cube plus 3. Okay, what is the remainder when 2020 plus x to the power 2022 is divided by 8? Chalo, let's see. 2020 plus x to the power 2022. This means 2020 plus x. X is nothing but 4 cube plus 3 to the power 2022. Remember, the aim is it divisible by 8 or not? Or what is the remainder when it is divided by 8? So 8 is my divisor. Here what do I get? I get, okay, 2020 plus 4q plus 3, all of this to the power 2022. What do you think now I should do? What do you think now I should do? Tell me. Tell me. Any idea? Any idea? Quick, because I'm about to give you a hint. Come on. So many questions we've done on remainder. This one, I feel you can do. Remember, what did we have? See here. 2020 plus 4q plus 3. Okay. Now, basically, what I want you to understand is this part that we have segregated, this is a multiple of 4. This completely is a multiple of 4. Yes or no? So I will get this 2020 plus 4q. 2020 is a multiple of 4. 4q is a multiple of 4. Take out 4 common, inside whatever is left, treat it as lambda. So 4 lambda plus 3 is your final expression. Now 4 lambda plus 3 to the power 2022. Oh my god. 4 lambda plus 3 to the power 2022. So you do like this now. Now you will get 16 lambda square plus 9 plus 24 lambda to the power 1011. Now your divisor is 8. So what will you do? You will have 8 into 2 lambda square plus 8 into 3 lambda plus 1 and then plus 1. Why? I wrote 9 as 8 plus 1. Alright, all of this to the power 1011. Is this correct? See, I'm playing so smart. Is this correct? Cool? Cool? Now this completely, let's say, is capital K. So 8k plus 1 to the power 1011. Now you know I have expressed my base as multiple of 8 plus 1. So this multiple of 8, bye-bye, go went gone. You are left with 1 to the power 1011. That means 1 is your final answer. Such a brilliant question. Such a brilliant question. If the remainder when x is divided by 4 is 3, then the remainder when this expression is divided by 8 is 1. No connection. Such beautiful question. Such beautiful question. All right, is this clear? Everybody, can I move ahead now? Can I move ahead? Yes? Very easy peasy properties of binomial coefficients. I think I don't need to prove them to you. It's very obvious. First of all, when you write x plus y to the power n, you end up getting nc0, x to the power n minus 0, y to the power 0, plus nc1, x to the power n minus 1, y to the power 1, plus nc2, x to the power n minus 2, y to the power 2, plus and so on, ncn, x to the power 0, y to the power n. So when you plug in x as 1 and y as 1, what you end up getting is 2 to the power n, and right hand side becomes nc0 plus nc1 plus nc2 and so on ncn. This is what is the sum of binomial coefficients in the expansion x plus y to the power n. Please remember this thoroughly. Remember this thoroughly. Okay? One more thing. When you write the expansion of x minus y to the power n, what you end up getting? nc0, x to the power n minus 0, y to the power 0, minus nc1, x to the power n minus 1, y, then plus, then minus, and so on. Correct? Last term is ncn, x to the power 0, minus 1 to the power n, y to the power n. Yes or no? Here, if you plug in x and y as 1, what you end up getting is the second result. First is already proved. You end up getting the second result, that nc0 minus nc1 plus nc2 minus nc3, alternate plus minus sign. The answer is always 0. Got it? But this gives you even major conclusion, which is something which is not very evident, is this. See, when you say nc0 minus nc1 plus nc2 minus nc3 plus nc4 minus nc5 and so on is 0, what you are actually saying is that nc0 plus nc2 plus nc4 plus and so on is equal to nc1 plus nc3 plus nc5 plus and so on. So even lower indices, sum of binomial coefficients, is equal to odd lower indices, sum of binomial coefficients. Even lower indices, sum of binomial coefficients, is equal to sum of binomial coefficients with odd lower indices. This is the same. But if this is the same, if the sum is the same, the sum of all of them is 2 to the power n. The sum of even plus odd is 2 to the power n. The sum of even is same as sum of odd. So sum of even is 2 to the power n upon 2, which is 2 to the power n minus 1. Sum of odd is 2 to the power n upon 2, which is 2 to the power n minus 1. Did you understand what I said? Sum of everything is 2 to the power n, right? Yes or no? Yes or no? If sum of all of this is 2 to the power n, this is nothing but sum of even plus sum of odd. That means sum of even lower indices binomial coefficients plus sum of odd lower indices binomial coefficients. This is 2 to the power n. And both these sum is same. Both the sums are same. So twice of sum of even is 2 to the power n. That means sum of even is actually 2 to the power n minus 1. Similarly, sum of odd is the same. This is what is very important. All these 4 results you have to keep on your fingertips. Must remember. Must remember. Okay? Cool. Now come to this question. What do you think will happen here? 1 upon 1 factorial into 10 factorial plus 1 upon 3 factorial into 8 factorial plus and so on. What do you think is the answer? What do you think is the answer? Jaldi batao. What do you think is the answer? Quick, quick, quick. Quick, we have solved so many questions and now I feel you should be able to give me the answer of this question. The results are shared with you. The results based upon binomial coefficients are also shared with you. The trick used here, very first trick used here is multiply and divide by 11 factorial. Anybody? Multiply and divide by 11 factorial, because divide by 11 factorial, multiply, you will get 11 factorial upon 10 factorial into 1 factorial, plus 11 factorial upon 3 factorial into 8 factorial, plus 11 factorial upon 5 factorial into 6 factorial, plus and so on 11 factorial upon 11 factorial into 1 factorial. How did this hint pop up in my head? Because 1 plus 10, 11. 3 plus 8, 11. 5 plus 6, 11. 11. This is also 11. Okay, this is 0 factorial. Is this cool? This gives you 1 by 11 factorial. This is 11C1 plus 11C3 plus 11C5 plus 11C7 plus and so on 11C11. Guys, when you write x plus y to the power 11, what is the status of binomial coefficients? You get 11C0, then 11C1, and so on till 11C11. The sum of all these coefficients is 2 to the power 11. The sum of binomial coefficients with even lower indices is 2 to the power n minus 1, 10. The sum of binomial coefficients with odd lower indices, sum is 2 to the power n minus 1, 2 to the power 10. This is sum of all binomial coefficients with odd lower indices. 11C1, 11C3, so on till 11C11. So your answer will come out to be 2 to the power 11 minus 1 upon 11 factorial. So 2 to the power 10 upon 11 factorial. So your k is nothing but 10. Not 11 Naresh, k is 10. K is coming out to be 10. All right. Everybody, are we set? How to